Hi everyone. Welcome to the Overmark September EOY revision class. Yeah, so this is the revision for Sec 3 IP Physics. Okay, so before I begin, let me just do a little bit of short introduction in case maybe some of you all are like new to Overmark, like you never even know this tuition center, or maybe you never even seen me before. Yeah, so just to give you a little bit of a self-introduction first, so that at least like you know like who I am and all. Yep, so this is my name. So later during the lesson time, if anything unsure, you want to ask question, you can just call me as like Miss or you call me Teacher Felicia also can. Yep. And for me, why am I teaching your IP is because I specialize in IP. That's why. Yeah. So for me, I teach Sec 1 to Sec 4 mainly IP classes. So I teach lower Sec science. For upper Sec, I teach IP Chem and IP Physics. So before I joined Overmark, previously I was actually at the other tuition center called the Learning Lab, where I was there teaching for like 7 years. And before the Learning Lab, I was actually at another tuition center called Wisland Education. And I also did like quite some MOE secondary schools relief teaching, yeah, at the various schools. So far these are my track records. Majority of my students are usually from NYGH lah. Yeah. Okay, then yep, so a little bit more about myself is that I like to travel and I also love to watch Korean shows. So for my students, they will know that like usually during my lesson, sometimes I will bring in like my K-drama show that I watched before. Then they will be saying that, teacher, I think you watch a bit too much show, yeah, because like I keep on like to bring in those like very like funny clips in the K-drama to bring it into the lesson time. So they're easier to remember also certain concepts. Yeah, then for me it's like while I'm traveling, I still won't forget about my passion in teaching. So this was me when I went to Switzerland. Yeah, so it's like when I was like high up at the Alps. You know, right? When you are at high altitude, it will be of very low pressure. So if it's at very low pressure, then it would be like causing that means the surrounding air is very low pressure such that this is what happens. So you see, even though I am traveling, I still remember about physics. So can you see that the whole sandwich became very round and full? The reason is because for the low altitude, the surrounding pressure is very low. That's why it becomes pressure inside the very high, pushing outwards. That's why it caused my whole like sandwich to be like almost about to explode. Yeah, so that's low pressure at high altitude. And then since I like K drama, then yeah. So when I see, oh my god, crash landing on you, then yeah, I quickly like took a photo. Okay, for the two of you who just came in, I think there's one chair near the snack there you can take that seat, and there's one seat, right? So enough seats, right? Yeah, there's one more seat in front also if you need. Yeah, there's one more chair in front. Okay, then for the both of you who came in late, I'll need to see your tickets. So can you stand by your phone the tickets so that I can check your tickets? Okay, then next would be I also like board games. So actually at home I got a series of a lot of board games, you know. Yeah, so for me is that like I like board games so much that sometimes I will even bring it to the classroom. So this is one of the games that I play with my students, which is called Wet Heads. You can see it, that is over there. Yeah, so I actually do use it during my lesson time. It's the yellow helmet. Yeah, so in there it will be like 8 sticks where only out of 8 only one will leak water. Yeah, so this is mainly like to make my students study, you know, because certain things like very important, must study. That's why I make them study. Then next lesson I'll test them. So to test them, I'll usually use the wet heads all because like if you never study, they need to pull one stick, then it will be up to your own luck already, right? You see whether you're lucky or not. Yeah, since only 1 out of 8 will get wet. But those who studied, then they will need to wear the helmet lah, because they did study, why would I punish them? Yeah. So yeah, then this is another card game which is like on chemical formula, which is called ions, which is also up there lah. Yep, so these are things that I did in my class. Okay, so enough about me. So now about Overmark. So no worries, you are in safe hands, you are in good hands, because Overmark is a well-established tuition center where we have 1,000 over students every year. So that means actually since Overmark has been here for a few years, we actually have a few thousand students graduated from us already so far. So Overmark can be found in the various locations. So maybe in future, one day you will to be considering of having tuition. I can see which branch is near your school or maybe near your house. Yeah, so need not be Bukit Timah. There are other branches available also. So this is so far our social media reach. Yeah, so I would recommend that you follow us on social medias because that's where we will actually post announcements like today's this kind of free revision event. So we will post it on our social media. So if you want to receive more freebies, because sometimes we also even have like webinars. Yeah, so like maybe next year, you know, when you are in like JC, you want to decide, okay, sorry, in Sec 4, you want to decide which JC subject you want to take. We also have like the JC subject webinar. Yeah, so we actually have like on and off a lot of different kind of events. So if you follow us, then you can get up to date on all these events. Yep. And then for Overmark, we also have a YouTube channel where the lesson recording of today's lesson will be actually uploaded onto Overmark's YouTube channel. So if today's lesson you feel that, oh, I want to revisit the lesson, you want to rewatch the recording, can. You just go onto Overmark's YouTube channel at the end of the event. That means they will post it only when school reopens. Yeah, then in there are also the past year's revision events. Yeah, so there are a lot of recordings out there. Yeah, so if you find that maybe certain subject that you are weak in, yeah, you can just go to Overmark YouTube channel. Yeah, there are a lot of recordings that you can actually watch. Yeah. So far this our achievement. Yeah, so the teachers here are all very qualified. Yeah, because we all come from like prestigious schools. Yeah, and then a lot of us have like a lot of teaching experience also, so no worries, you're in good hands today. Okay, so as our students, I think some of you are already Overmark students. Yeah, so for Overmark students, you all know, right, that we'll actually give you like the book of like curated notes. So even if you join tuition like quite late, maybe like now you feel that, oh, I didn't want to join tuition, but when you join, we'll give you the book of curated notes, which consists of the first topic in Sec 3 till the last topic in Sec 4. Yeah, so it's like even if you miss the tuition for the front part, you can still catch up with the notes. Yeah, and that whenever WA is nearing, we will revise for your WAs. And then if there's exam coming up, then we will be doing more exam. Like for my own classes, I'll be doing more exams sooner at like late September, early October. Then if you all have practicals, then we also do science practicals too. Yep. So that's the benefit of being Overmark students. And another benefit is we actually have a free flow snack bar, which is at the back. Yeah, so later during the toilet break, you can help yourself by the snacks and then you can eat it in the classroom during the lesson. Okay, so that's all for the introduction. Let's begin with the lesson now. So for online attendees, make sure that you have the lesson material for today. If not, you have to scan the QR code at the top right corner if you didn't collect the lesson material at the centers yesterday. Okay, so let's begin now with the lesson material. Yep, so this is the lesson material that you're supposed to collect. Hold on, let me just do this. Okay, so this would be the 3 chapters that we will be going through today. Because it's just a 3-hour lesson, I can't possibly go through every single topic you need for EOY. Yeah, so we selected like the 3 topics that we feel that likely you all might have misconception and might be struggling in. So this would be the 3 chapters. We start off with the topic on dynamics first. Okay, so for the topic on dynamics, so you need to know that for dynamics is actually there is a concept called inertia. So what is inertia? Inertia is mainly about trying to remain the same. Yeah, so for example, if the object it is stationary, it will want to remain stationary. And then if the object is moving, it will want to continue moving. By the way, just to let you know that for my lesson style is that usually I will like write down things and then I will highlight things. So can you follow and note it down on your copy too? So that means whatever that is shown on my screen should be the same as your worksheet. So you see, if I wrote this, you follow and copy it down. Okay? So need to know the meaning of inertia is the reluctance to change. But don't need to memorize the definition. Yeah, because just need to know what it is, will do. They only ask you to apply. So it's mainly testing you on application question. Okay, then next would be mass versus weight. Mass is in kg, while weight is in Newton. So what's the difference? So for mass, it will be the amount of substance in it. So it's like the amount of matter in it. And then for weight, it will be based on how much gravitational force. That's why if you were to go to another planet, then the value will change. Okay, that's why they mentioned here, mass won't change, but weight will change. Next, gravitational field versus gravitational field strength. If you talk about gravitational field, right, it will be something like, soccer field. So what's soccer field? Soccer field is the area where you play your soccer, correct? So field is just a region. That's why here they mentioned that it's a region. But if you talk about field strength, strength is like, example, if I say that, oh, this guy was very strong. Very strong means what? He can lift up very heavy dumbbells and weights, right? So that's why when you talk about strength, it's about how much force the guy can lift up. That's why gravitational field strength is about the force per unit mass based on his body size. That's why body weight lifter, they also have like different weight category. Yeah, so based on your weight category, you fight with and compete with people of similar weight as you. Okay, then next would be the Newton 3 laws. If you were to refer to the learning outcome, right? Newton's 3 law, they won't ask you define Newton's first law. No, they won't ask you to define the law. What they will ask you is application question. So for Newton's law, as mentioned here, don't need to memorize, okay? Just need to understand what it is about. You can apply to worksheet question, will do. Okay, so for example, for Newton's first law over here, what is it about? We would say that Newton's first law is about no resultant force. Copy it down. So when there is no resultant force, what happens? Object at rest will remain at rest. Object moving will continue moving and then move in the same way. So that means they'll move at the same speed, same direction, everything the same. Yeah, this is when resultant force is zero, which kind of makes sense, right? Like for example, if like an object don't have force, obviously if there's no opposing force, it won't slow down. Or if the object no pushing force, it won't speed up. That's why by right, if no force or no resultant force, the object should be traveling in the same manner. So that means it will just remain in the same speed. So all this happen when resultant force is zero. But if you were to have resultant force, if you have resultant force means you need to calculate already, right? That's why you will need to use this formula, which is the resultant force is equals to mass times acceleration. Then again, as per usual, need to know all the SI unit. Force is in Newton, mass in kg, acceleration is meter per second square. And next is, usually if there were to be calculation question, let me teach you a special technique that I teach my students. So this is like my technique that you won't learn it in your school one because your teacher won't use this technique, which is I will usually go with this thing called the L-shaped method. So what is this L-shaped method? Okay, so first is, because force is a vector quantity, there is direction. So first is, you must always define which side is the positive direction. Like, is it upward or downward is the positive direction? You state that first. Then you do this L-shaped method. So what do I mean by the L-shaped method? It will be this, where the bottom of the FR over here, you write in the formula. So below it, you write the formula, which is MA. On the right side of it, you fill in based on the free body diagram. Okay, so what do I mean? You follow and copy it down first. After you're done copying, then I explain to you. So once you use this L-shaped method, right, no matter is it easy or difficult question, you confirm can solve it one. Yeah, so it's like the one of the best method to use. Yeah, so try to learn to pick up this method from today onwards. Okay, so you know what's free body diagram, right? Free body diagram means like, you know, this kind of box. Yeah, then maybe if they were to say that the object is moving, then maybe like a friction. Yeah, so based on the free body diagram, maybe you can put in force minus friction, something like that. Or if the forces are vertical, then you put in the vertical forces. So on the right side is always based on what you see in the free body diagram on the right of FR. Below FR, you sub in the formula. Then later, the question usually will give you some values. You just sub in the values. Let me demo to you how do you use this L-shaped method. Let's flip to the back. There is actually worksheet fashion. Just to check everyone done, popping, right? Okay, I'm moving on in 3 seconds. If you're still not done, maybe I'll take a screenshot. Then I'll move on already. So 3, 2, 1. Okay, moving on. Let's take a look at question number 1 of the worksheet at the back. Over here. This question here, come. Let me demo to you. How do you use this L shape? An object of mass 2 kg is initially at rest on a rough horizontal surface with a limiting friction of 1 Newton. That means the friction maximum, it will only be 1 Newton. And that a constant force is then applied immediately to the object for 4 seconds and then remove. And they asking you what is the speed of the mass at 6 seconds. Okay, so how do you do such question is you do one by one law. So like for the first paragraph, you solve first. Then second paragraph, then you solve again. So for the first paragraph, what you can do is, remember I told you, use the L shape. So now, if the object is moving to the right, we will take the rightward as positive. Yeah, copy it down. So taking rightwards as positive. Then let's copy down the L shape. I'll recommend that you box up the L shape also so that you can see clearly that what this L shape is. So based on this free body diagram, what's the right word force? You can see over here, right? It is 4 Newton. So I'll write it in 4.0. Any more force present in this diagram? So what other force is present in this diagram? Friction, correct. That's why you have to, friction always oppose motion, right? That's why for friction, you have to minus because it is to the left. Since right is positive, left would be negative. So this time around, I minus the friction, which is 1.0. So now I simplify it. This will be 3.0. Then next you start in mass. Mass is 2 kg. Then A, we leave it. So that's why now we know that, okay, the acceleration is 1.5. So even though you see, the question never asks for acceleration, but you just use the L shape. Somehow the L shape will give you values that you need later. So even though here, I don't see a need for A, but actually you need the A later. So no worries, just follow the L shape. Trust in the L shape, okay? Okay, so done for the first paragraph. Now we continue to solve for the second paragraph using the L shape again. So for this question here, they said that a constant force 4 Newton applied already, right, for 4 seconds, then they remove it. Yeah, so that's why in this case, they're asking you what is the speed at 6 seconds. Okay, so that means this time round, by right, you should draw out a graph lah. Easier to visualize it. Yeah, so let's draw out a VT graph. So for a VT graph, do you realize that at the start, they say initially is at rest. That means U is 0. So you must start from 0. Then you have an acceleration, right? Acceleration means it will speed up. And do you also remember from the topic of kinematics, how do you tell acceleration in a VT graph? So which part of the VT graph tells you the acceleration? So what is it? Area, oh no, not correct. It's gradient, so must revise. Good that you came today, at least we are revising. Yeah. So yeah, the gradient over here will tell you the acceleration, which is 1.5. Yeah, write it in. And how long do you accelerate? You based on the question, they accelerated for 4 seconds. That means this would happen until 4 seconds. Then now you remove the force. So what do you expect would happen to the speed if you remove this forward force? And then you still got friction. So the object will, what happened? The object will decelerate. Yep, it will come down. And then now they ask you for 6 seconds. So let's find out the value for 6 seconds. So you see now the acceleration come into picture already, even though the question never asks you to solve for acceleration. Okay, then next is now that we have the value here, so to find out the speed at 6 seconds, that means I need to see how much it slowed down. So that means you should actually go and find out what is my higher speed so that I know later, 2 seconds later, how much you slow down until. So how can we find the speed over here? You have the gradient and the acceleration value of 1.5, right? How do you find the final speed? You have the initial speed, right? Initial speed is 0. How to find the final speed? So what's the formula to use? What's the formula?
A equals V minus U over T.
Yes, correct. Thank you, Noah. Yep, so now let's use the formula. A equals to V minus U over T. So now can you sub in the values and tell me what number can you get for this V value over here? Since those online like not participating, I'll get those online to answer my question, okay? So I start off, I go by alphabetical order, but I go reverse. So I start from Zhenin first. So Zhenin, once you manage to solve for the value of V, can you let me know what answer do you get for the V value? The people, if you don't want to use the acceleration formula, another way is you can use the gradient formula. You know, gradient is like y2 minus y1 over x2 minus x1. Yeah, so you solve for this line here. Can I confirm it's turning around? Zhenin not around, is it? Okay, then later I come back to Zhenin. Then I move on to Xavier next. So Xavier, do you manage to get the answer of the V value here?
V value at 4 seconds.
Again, louder please.
6 meters per second.
Correct, thank you. Yep, the answer is 6. Anyone can get 6? Need me to show you the working? Don't need, right? Can get, right? Okay, great. Let's continue on. Okay, so now that we get the value of 6 already, then what is the question? The question is asking you for this speed over here. Yeah, so how do we know what is this speed over here? Same thing, we haven't used the L-shape method yet, right, for the bottom half. So now let's do the L shape for the second half, which is over here. Okay, so for the L shape, let's do it again. So this time round, the object is still moving to the right, just that it is slowing down. So we still take rightwards as positive. Okay, so that's why I still taking rightwards as positive. Let's write in the L shape again. So below FR, you write the formula MA. On the right, we base on the free body diagram. So now, let's take a look at this free body diagram. If you remove the 4 Newton force, so what's the force left? So what's the force left? So maybe I move on next online, it will be Skylar. So Skylar, what happened to the resultant force now? So what's the force left in this free body diagram?
2.
Cannot hear you. So which is the force that's left in this free body diagram after you remove the force?
Is it 2?
Maybe can you tell me what's the name of the force? So you look at the picture here. If you remove this 4 Newton force, what is the name of the force that's left? Or can anyone help Skylar since he seems to be stuck? Friction that is left, right? Because once your 4 Newton gone, you only left with friction. Yep, so that's why let's write down that your force is actually friction. And friction is in the which direction? Is it to the right? Friction is opposing motion, right? It's to the left. So you need to put in the negative sign for friction. So it's minus friction. And then now, let's write it in. So friction, what's the value? Friction, they say that it is 1 Newton. So let's write it in 1.0. Then continue sub in all the values. What's your M? Your M is here, right? 2 kg. Your A, we do not know. Right side is negative 1. Same thing. Can you solve for A? And can you finish up the whole question? You see whether can you get the correct option? Yeah, you give it a try. Finish up the whole question now. Then once you are done with question number 1, right, can you move on to do question number 2 also? It will be similar. Also use the L shape. Use the L shape, you will be able to solve it. You try now? Yeah, do question number 1 and 2 now. Then since Skylar didn't manage to answer me accurately just now, then can Skylar give me the answer for question number 1? Yeah, so after you solve it, you let me know your answer. By the way, meanwhile, you all are doing your work because I will need to mark attendance. So I will just go around to ask you for your names lah. Okay, so you just do your work. Meanwhile, I mark attendance. Okay, so okay, so can I get your name, please? Cannot hear. Oh, okay, can. Raphael Lim, right? Okay, can. Then you are? Zhao Kai. Let me find Why my name is very long. Trying to find. Oh, maybe I try control L. Okay, how to spell your name? A-N-G Z-H-A-O-K-A-I. Wait, I think I need to add spelling, spacing. Ang Zhao Kai. 3 words, right?
Yeah.
I cannot find.
Was it around now? Can we ask you?
Okay, I try.
Yeah.
Yeah, found.
Yeah, okay. I don't know also. I don't know.
Yeah, do question number 1 and 2. Same style. Question 2, use the L shape. Then you are, your name is
Okay.
J, J-U-S, okay, T-I-N-E. Okay, found. Thank you. And then, next, can I get your name, please? Hello, your name? Not here. Oh, Melody, okay. Then beside Melody is J-A-N-E, is it? J-E, J-A-D-E. Oh, okay. Then next you are? Cannot hear. Wait, can you speak a bit louder? I really cannot hear you. R-U-I-G-I-A. R-U-I-G-I-A. J-I-A. Cannot find. R-U-I spacing J-I-A, right? Or one word? One word. Oh, okay, found. Then besides Rachel is? Victoria, okay. Then beside Victoria is? Naomi. Okay, thank you. Okay, so I shall go through the answer now for question 1 at least. So Skylar, how have answer or not? Is
I'm really confused right now.
don't have. Okay, can. Okay, so Skylar, at least have you calculate what's the value of A?
Is it 0.5? Negative 0.5.
Correct. So if A is negative 0.5, that means the A over here is negative 0.5, right? So for this section over here, you use the formula A equals to V minus U over T. Your A value is negative 0.5. Then final speed is the one that you are supposed to solve, right? You leave it as V. Initial speed is 6. And what's the time duration for this section? 2 seconds. Then you solve for V. That will be your MCQ answer already. Okay?
All right.
Then you can let me know what's your final answer. How people can do question 2 or not? So how, Skylar, what's the option?
C.
Yes, correct. So people answer is C for question number 1. Can? Okay? Yeah, so you just need to solve this part for the V value will do. Okay? I move on. Okay, so moving on to question number 2. I don't know whether have you attempted it or not. Yep, so if you're not done with this yet, you can listen to my explanation. So for those of you who managed to do it, what answer did you all get? I can let you know whether you're correct or not. Yes, very good. The answer is C. Correct. Okay, so how do you get the answer of C? Use back the L-shaped still. And then you remember just now for the previous question, what did I do? Do you realize I do paragraph by paragraph? I did first paragraph, then second paragraph. So each paragraph, I use the L shape. So over here also same thing. Each box, you use one L shape to solve it. Okay, so now we just do box by box. We start off with maybe the left side box over here first. Let's use the L shape. So this object is moving which way? This object is moving to the right. So we will take rightwards as positive. So the reason why I ask you to write this statement, which a lot of students tend to be lazy, then they will skip it. The reason is because to prevent careless mistake. Like you see just now, the friction, you must put like minus friction. Yeah, because it's in the opposite direction. So this is to reduce careless mistake. So if you know that you are the kind that always make careless mistake, right? Best is write down this statement. Okay, then now let's write down the L shape. Below FR, you write the letter MA. On the right is the free body diagram. So based on this object here, do you realize there's a string pulling it to the right? That means there will be a tension towards the right. And this time around, they say it's a frictionless pulley. That means there's no opposing force. So the only force, it will be only tension. But tension, you don't know the value. I will just copy it as letter T. Okay, so this would be your L shape. Can you box it up to make it more obvious so that you know that, oh, this is the L shape method. Then now, continue to sub in the values. The mass for this box is 8. The acceleration is not known. It's okay. Because later, this will be your simultaneous equation number 1. Because of 2 unknown. Okay, so done for the left side. Let's move on to the right side box. So same thing again. This time round, let's define the positive direction. This box is moving which way? This box is moving downwards. So that's why you take downwards as positive. So now, same thing, write out the L shape again. So on the bottom, you write in the formula. At the right side, you will write in based on the forces that you see. So if there is a box of a mass, obviously there will be a weight, correct? And there is a string. String means there will be tension upwards. That's why if downwards is positive, means W is positive, tension would be negative. And now let's sub in whatever that we know. W, the formula is mg, correct? So let's sub it in. The mass is 5. So I'll sub in the mass of 5 on both sides. Then acceleration, we don't know, right? You leave it as letter A. Next, G, you all know, right? You will be, okay, for this question, they never define, but based on your schools, because some IP schools use 10, some schools use 9.8. Yeah, so let's standardize, okay? So maybe we take it as 10 first for this question. Okay, so if we take G as 10, but tension, we don't know, right? You write as minus T, oh. Then now what's the question asking you? The question is asking you to solve for the acceleration. If you want to solve for the acceleration, means you should sub the T away. So that's why now you should sub the T to become 8A. Okay? So now can you solve the simultaneous equation now? Sub T as 8A. So this T should become 8A. Then with all the A's, you solve for the A law. That's it. And since they are traveling using the same string, their speed and acceleration will be the same. So the A's are actually the same values. Yeah, so solve now. Sub 1 into 2. Then by right, you should be able to get the answer of C. In 2SF. So you see, as long as you use the L shape, no matter how difficult the question is, you will be able to solve it out still. Come, let's try one more time, okay? The L shape, see whether you can make it or not. Okay, so now can you all go to question number 11 once you are done? So once you are done, do question 11 next. Then meanwhile, you all are doing your work, I continue to mark attendance. Okay, so you are? What? D-A-L, is it? E-N-L-E. Got spacing, right? Okay, can, found. Okay, then beside Enle is, can you help me tag him? Yeah, what's her name? B-E, then? B-E-N-N. Okay, can, I found. Then beside Bennett is? Ashton. Okay. Then I continue to mark attendance. You are? How to spell? You can also. K and J only. Letter K and letter J. Yeah, I found. Okay, can. Then next you are? Isabella. Okay. Then beside Isabella is? Rachel. Your Rachel, how you spell? R-A-C-H then? E-L-L-E. Oh, okay, no wonder. Then beside Rachel is? How to spell? Just put QH only, huh? Okay, can. I found. Okay, then next you are? Your name is? Yeah. Justin. Okay. People finish up question 11, please. Do now, do now. Justin, did I ask you for your name just now? Eh? Wait. Oh, no wonder. Okay, okay. I was like, eh? Okay. Justin, your surname is N-I, is it? Oh, okay, can. Sorry, I got confused for a moment. Okay, then next you are cannot hear. J-I-A-N? Okay, found. Okay, then next you are J-E-R. Fine, ah.
I don't understand. Is it there was the one that seems yellow, right? Huh? It's like one second. Wait.
Jerlyn, can I check with you? Because there's two Jerlyn Lim in my attendance. I don't know which one is you though. There's one that is I think both are you, is it? The phone number is the same, but email is different. Oh, okay, 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 can, it's okay. You double register. Okay, can.
Yeah.
Wait, teacher,
Yeah, can hear.
for question 1, right, may I ask how you got 6 again?
You use the formula A equals V minus U over T. So the V is the speed that you need to find at the 6-second mark. Then U is the initial speed of that downward sloping line. So the initial speed is 6.0, which you can see from the y-axis. Then the time, it will be 4 seconds to 6 seconds. That will be total 2-second duration. So your denominator T is 2.
Okay.
You need me to repeat any part?
No.
I got it for just a few. Let me put them first. The immediate I don't know if they are everything. Wait, so I'm saying two three. Are you sure? Oh,
Okay, continue with the attendance. So, yeah, hi. Yeah, so what's your name? Yeah, cannot hear. Jolene. Oh, yeah, I just I marked already, right? Okay, can. Okay, then I continue on to the first row. What's your name? Okay, look, start with letter C, is it? Okay, can. Then beside Caleb is what? Jaden. Okay. Then beside Jaden is can. Then next will be Yubin. Okay, can. Okay, so should be more or less done with question number 11 by now. I shall go through the answer now, okay? Okay, so for question number 11 here, yeah, Yep, so here's the answer. So for the first part over here, they're asking you to describe the acceleration. So how do you deduce that the answer is constant, then decreasing? Okay, so things to take note of. Okay, so I explain the graph first. Okay, so you need to know that if your resistive force is constant, and then you look at your forward force. So for your forward force, they say it's 600 Newton, right? And then your resistive force is 20. That means at the start, your resultant force is 600 minus 20, which is 580. Do you realize it is actually a constant value? Yeah, so if your resultant force is a constant value, then you base on F equals to MA. If your F is constant, that means your A will be constant, right? Yeah, so that's why in this case, your A is constant. So this is the answer for the first part. The answer for the second part over here, they said that the answer is decreasing. So why is the answer decreasing? It's because same thing, you look at your resultant force again. So for our resultant force here, do you realize that it will be the forward force of 600 minus the resistive? And the resistive force, do you realize it keep on go up and up and up? It means my value keep on getting bigger and bigger and bigger for the resistive force. So what happened to my overall resultant force? You keep getting smaller and smaller, right? That's why if my resultant force keep decreasing, based on the formula, F equals ma. If F decrease, means A will decrease. That's why the acceleration will decrease. That's why they wrote the word decrease. Next, this is not enough still. So the next mark they need to get is because whenever they give you graph or table, there's an important skill set they need to remember. Whenever graph or table is given, you need to, what do you need to do? Do you know what to do? I need to code data. Very good. Yeah, so you need to code data like the value of like 10. Okay, you see? All these numbers. Yeah, so need to code the data. So if you just say that, oh, the acceleration is constant, then decrease, full stop, like that, right? 0 marks, you need to code data. So I need to have numbers like the timing. Did you code the data? If no data, 0 marks, must code data. So must remember, okay? This is a skill set you need to have even for chemistry. Yeah, even for Sec 4 next year, need to have. Okay, so must remember, must code data. Can you write it down at the side to remind yourself? Whenever got graph and table, must code data. Okay, so I shall move on to the next part over here. Okay, so for the next part, it will, oh no, wait, Okay, so for the next part over here, the answer is 3.9 in 2SF. Yep, so this is because if you look at the question, the numbers are all in 2SF. You look at the graph 2SF. Here, 2.0 to 2SF. This is 2 or 3SF, but we always choose the least SF. So final answer, 2SF. Okay, so for this question, how do you do it? So I will not recommend you to use this. Okay, maybe can I change? Let's change the method. Okay, let's not use this. Let's standardize. Always use the L-shaped method. Because if you keep using the L-shaped method, once it comes to you as like a standard way of solving, then you will know how to solve all kinds of questions. So same thing, using the L-shaped method, it would be below, you write down the word MA. On the right, you see the diagram. What kind of force is happening? So they say that the person got a forward force, right? That's why I will have a F forward. And this time round, the graph showed you a resistive force. That's why you should minus resistive force. That's why now we can sub in whatever values that we can see. So what's the forward force? It's given in the question you read. It's the first paragraph. It is 600. Then now they are specifying at T at 5 seconds. So go and check at 5 seconds, what is the resistive force? So how much is it? Can you read the graph? What's the resistive force at 5 seconds? 20, correct. Then now continue sub in the number. Then the mass is here, which is 150A. Then this one is 580. Then just solve for A. Then by right, you should get the answer of 3.9 in 2SF. Okay? So people, you see, just keep using the L-shaped method. Then you will be able to solve most of the question already. Okay, so I shall move on. You all are at least done with part A, right? Part B, I'll leave it here so that you can still see it when I go to the next page. Okay, up like that then. Come, let's check your answer for part 2. The answer in 2SF is 41. People, no worries, okay? If you are slow in writing, you can't finish the correction, I will be giving you the answer key at the end of the session. You just need to stay till the end, I'll be giving you the answer key. Okay, so no worries if you can't finish your correction. Yep, so for this part here, you just use the formula, the A equals to V minus U over T. Just type in, done already, that's it. Can? That should be okay, but quite straightforward.
Wait, so you said velocity and speed is like interchangeable?
Velocity and speed is kind of interchangeable use unless the question got specified that like one got direction versus one no direction, then you have to use the appropriate one. But if not, both are referring to how fast the object moves. So both are still in meter per second, so it can still interchangeable. And final answer, do you write in 2SF? Okay, so moving on to part C. So for part C, they're asking you to sketch and label a graph. So this would actually be the answer. Yours should be, okay, I move this up. Okay, so this is how you draw the graph. You draw first, you do your correction first if wrong. After you're done with correction, then I explain to you part C. You draw first. I'll explain to you part C after you are done with correction. And for those of you who got it wrong, I'll recommend that you do it in green pen so that next time when you revise, you can know that, oh, this question last time I got it wrong because it's green color, so must revise. Then those that you get correct, don't need to revise anymore. Yeah, so in exam, right, you know, there's so many things to study, right? Got notes to study, got so many worksheets to revise. How to revise finish? You revise the ones that you got wrong. Because those that you got wrong means you couldn't score, right? If you cannot score, then suddenly now you learn from your mistake and you can score. Isn't that an improvement from cannot score become can score? Yeah, so that's why I will always recommend my students correction do in green pen because that's to highlight to you. Okay, this one green pen means I need to revise in the exam, so you can strategize when time is like a constraint. Yeah, so you only revise those that you got wrong. Yeah, then you can improve. Yeah, from don't know become you know how to do it now. Yeah, so do in green lah. Yeah. Okay, I'll start to explain now. No worries, this graph will still be here. Okay, so how do you do this graph? Do you realize there are two sections? Why is there two sections? It's because you refer back to part A. In part A, what did we say? It is constant acceleration, then decreasing acceleration. So remember this, constant acceleration, then decreasing acceleration. That's why when you look at this graph over here, remember gradient of a VT graph tells you the acceleration, right? That's why in this case, if your acceleration is constant, then decrease, then you just follow the gradient should be constant, then decrease. So can you see the front part is constant gradient? What is constant gradient? Constant gradient means at the start and at the end, you realize the steepness is the same. This is called constant gradient. So take note, not horizontal line. Horizontal line is zero gradient, so don't get confused. So just a quick recap on math gradient. If it is diagonal line, it's called positive gradient. Horizontal line is zero gradient. That's why don't draw horizontal for constant gradient. You should draw it diagonal with same steepness. So if it's horizontal line, it's more of the speed is constant. But now I'm not asking for the speed. I'm asking for the acceleration. The acceleration is constant, means the gradient is constant. So it's upward sloping line with same steepness at the start and at the end. Next, when the gradient decreases, means that it should curve to become less and less steep. So can you see this part here? You see it's curving and become less and less steep. So that's called decreasing gradient. So take note, it's not coming down, okay? If you draw the line come down, that is decreasing speed. I'm not talking about speed. Based on part A, it is the acceleration. So acceleration decrease means gradient decreases. But the object is still accelerating. That's why the speed is still going up. Okay, then next is how do you sub in all these values? So for the number of 40.7, this is actually from over here, right? Can you see? 40.7. Yeah, so this is from the top part here, which is part 2 lah. So let me label it. It's from part 2. And then over here, this one was from part A. Next, how do you get the value of 60? So the value of 60 is given in the question here, right? So let me just arrow it. Yep, that's 60 over here. You get the number 60 here. Can? Because they said that at 20 seconds, it's 60. So you write, 20 seconds, 60. Next, there is also a number of 2 over here. Where do you get the number 2 from? It was from the question in part B. You write it down. So this is from part B. Let me show it to you. So if you look at part B, can you see the word here? The initial speed is 2 meters per second. If you miss this, can you highlight this part? The initial speed is 2 meters per second. Because of this phrasing, that's why you look at the graph y-axis. That's how you get the value of 2. Okay, so it's from part B. Then done already, also this will be the answer. So just make sure that you end at 60 meters per second at the time of 20. Then done. So the x-axis over here, it will be 10 seconds and 20 seconds because follow part A. And can you see part A is until 10 seconds and 20 seconds. That's why your axis over here, it will be 10 seconds and 20 seconds. Okay, that's all. Okay, so if you're not done with the correction, no worries. I'll be giving you the answer key. You can slowly write in the correction at your own time. I'll give it at the end of the session. Okay, so let's move on back to the notes because I only started like a little bit. Okay, so for the notes, we were at here, right? Yep, I was at Newton's second law using the formula. Let's now move on to Newton's third law. So for Newton's third law is actually the action-reaction force. So what is this action-reaction force? It is that you need to fulfill all 4 criteria. So if you fulfill only 2 out of 4, it is still not action-reaction force. You must fulfill all 4 criteria. And need to know that when you talk about equal in magnitude, that means like equal in values. Act on different bodies. Bodies just means object. And then opposite in direction, as well as same type of force. For the same type of force, right? The most commonly tested ones, it will be normal contact force. Yeah, because by right, I write shortcut can NCF, normal contact force. Okay, NCF is normal contact force. Because, for example, if I were to have maybe, okay, this is my writing tablet to write on the screen here, and then I have my water bottle. If my water bottle and my surface here, they are touching each other, that means my water bottle is pressing down on my surface. And my surface also pressing up on my bottle, right? That's why normal contact force, we can always say that it's opposite direction because one up and one down. And they are the same type of force. So the commonly tested one is normal contact force and gravitational force. Yep. So gravitational force usually can come in the form of weights. Yeah, but take note, okay, like if I were to say that if I let go this water bottle, what happen? It will drop, correct? Because of its weight. So take note that weight is by the earth on my water bottle to pull it down. So that's why if you want to reverse it, because it must be like opposite in direction and different bodies, then another way to write it is the action-reaction force of my weight, it will be the force by the bottle on the earth. That means in other words, right, when I jump, you can see the earth pull me down because earth is very big. Then they can pull me down easily. But when I jump, actually I am pulling the earth up. Just that you don't see the earth moving up, right? Why? It's because I am too tiny compared to the size of earth. That's why although I'm attracting the earth upwards, but you don't see the earth moving. That's why my students very creative. Oh, what if the entire human population, we all stand on one country, then we jump together, then will the earth move or not? So now my question is, if we all stand in one country, what's our size compared to earth? We are still inside earth, right? That means we are still tiny as compared to earth, right? So do you think the earth will still move? The answer is it won't move because we are still too tiny. Yeah, so just take note that the effect you can see based on their size. So you can see the earth pull us down, but you cannot really see us pulling the earth up. But actually, it actually happens. So gravitational force, the definition when you go to JC physics or if you take advanced physics, they will say that gravitational force is the attraction between two masses. That means as long as you got mass, they can attract each other. That's called gravitational force. So take note, okay, whenever they ask you identify the name of the force, like type of force, try to write these two. These two is usually the correct answer. And next is because they must be different object and must be opposite in direction. Usually the phrasing, how you write, right? You should always say that it's like the normal contact force by object A on object B, as well as force, normal contact force by object B on object A. So try to always use this phrasing. Exerted by B on A, as well as by A on B, to show that it's opposite in direction. Can you write this in? So this is how you phrase for your open-ended answer. Okay, then on the next part over here is on friction, which I'll go through more later. Okay, come, let's give it a try with question number 12C now. So can you all flip your worksheet and jump all the way to question 12C? See whether do you all know how to write or not. Yeah, just do question 12C will do. The A and B we see first. Just 12C will do, just this part here. So do you all realize this one is the section that I just went through, right? Action, reaction, force. And I told you action, reaction, force, I already narrowed down for you. Only got two possible answer, right? So you just choose within the two possible answer lah. Okay? Yeah, so I'm teaching you how to be street smart or book smart. Yeah. So since I already told you, the usual answer is the normal contact force and gravitational force. First choice, try to choose between these two. So you see whether can you choose either one of them or not. Then next hint is over here they write weight. Remember I just mentioned to you what's the name of the force that is related to weights. And I teach you already right how to write the sentence, right? The answering style. So can you apply the writing technique, the answering technique in? People, can you at least attempt it? Don't like wait for my answer, can like at least try it out. Yeah, because yeah, I will go through, but at least try out. Then you can learn that, oh, actually you answered correctly or you answer wrongly. Yeah, so give it a try, bah. It's okay to answer wrongly. Auric, no, different. Normal contact force is when you touch. Then weight is due to the gravitational pull on the planet, right? Like if you're on Earth, stronger pull. If you're on the moon, weaker pull. Okay, so I shall go through the answer now. Should be more or less done by now. So for auric, they need to be the same pair of forces because if you refer to the notes, they mention over here that Newton's third law, they have to be the same type of force, must be the same. Wait, what's my question? Just I was saying question 12, right? Okay, so for this question here, I shall now review the answer. So the answer will be for weight. Weight, it will be what is the name of the force? Gravitational force. So do you have the word gravitational force in your answer? If don't have, too bad, you need to do correction now. Okay, then next is, remember the answering technique, it will be by something on something. That's why this time round, what is the other force? Okay, so first is, what is weight? Weight is exerted by who? So for weight, weight is exerted by who? How come object got weight? This is exerted by, you don't know? By the earth, correct. Then on the object, right, which is the ball. That's why now if they ask you for the other one, you just need to make sure that it is opposite in direction. That's why the answer will be gravitational force. Then you reverse, instead of by earth on ball, now you change it to by ball on earth. Okay, so now is this sufficient? The answer is nope, because the question is asking you to describe, not state. So if the question says state, yeah, like that enough now. But they say describe, so you need to further elaborate. Yeah, so what about this gravitational force? This is, so can you go and look at the criteria? So one of the criteria is that it must be, what is it? Can you check the 4 criteria? So besides opposite bodies, what else? It must be equal, correct? It must be equal in magnitude and one more point. So you see, we already fulfilled the opposite, different object. And then we also identify same type of force, right? So we're done with same type. And then on opposite bodies and equal. What's the fourth one? What is it? Then different body already, mah. Ball and earth and ball. So it's different body already. So different body settled. Same type of
Opposite in
force settled.
direction.
Yes, opposite in direction. Very good. So this is how you can fulfill all four criteria in your answer. So I told you, right, must fulfill all four. So just make sure that your answer got all 4 points. Let's highlight it clearly since you're a bit like lost. Come, let's highlight. So first is the word gravitational force for both of them. This shows that this is same type. Hello, can you follow and annotate it? So this is the first criteria, same type of force. The second criteria will be, it must be on opposite bodies, right? Or different bodies. Can you see? Got 2 objects, earth and ball. So this would be different bodies. Then the third point, it would be equal in magnitude. That's why the last one, which I was asking you took so long to answer, it was opposite in direction. So total 4 points. And so this is how you piece your answer. You see all 4 points mentioned. So this is a very complete answer. Done. Okay, let's go back to the
Wait,
notes.
teacher.
Yes.
Isn't gravitational force always downwards?
No, because as mentioned just now, gravitational force is the JC definition, right? Is the attraction between 2 masses. As long as 2 objects can attract each other, there will be gravitational force. That's why, like for example, the Earth exerts gravitational force on the moon for it to revolve around the moon. But the moon is beside it, what? It's not on top below, it's not downward, but it's sideways. Yeah, so gravitational force can be sideways.
But then weight is always downwards, right?
Weight can only be downwards, correct.
Okay, thank you.
No problem. Okay, let's continue on with the notes now. Done, right? Okay, let's move on to the next part here on friction. Okay, so for friction, take note on the drawing because it can become quite tricky actually. Okay, so friction, as you know, it keep on resist forces. That means it always go opposite in direction. So for example, like this person walking, do you realize if the person is walking forward, yet the friction also forward. Like how come it didn't oppose motion? How come it's the same direction? Because for a person to walk forward, you need to exert a force backwards. So can you see? This is the force. And friction oppose motion. That's why friction is forward. Can just be careful that there are some special scenarios where the friction and the movement same direction. So this is one example. Can you follow and label the force in? Yeah, so that you can see clearly that the friction is opposing the force. Next part over here would be the bicycle. So can you see that the bicycle chain and the pedal is linked to the back wheel? So that means the back wheel is actually known as the engine powered wheel. Because like it's like an engine or like someone pedaling it. So we call it as an engine powered wheel. As compared to the front wheel, there is no bicycle chain. So if there's no bicycle chain, that means the front wheel is actually free moving. That means it's free to move. There's no force exerted on it. So now, if you were to decide what's the direction of friction, do you realize free moving versus engine powered? Even though my bicycle handle shows that I am driving towards the left, but do you realize the friction is totally opposite direction? Why? The reason is because there are 2 different types of wheel. For engine powered wheel, let's identify what are the forces present. So the forces present will be, I got the engine force, right, or the pedaling force. That's why number 1, I will have the force from the pedal or the engine. And number 2 is, if the surface is rough, there is friction. That's why I will have frictional force. Okay, let me scroll up a little bit. A bit cannot see. Hold on. Let me adjust it. Okay, so in this case, you all should know, right, that for example, let me use my writing pad again. If this is a slippery slope, and then let's take the cap of my water bottle to be the bicycle wheel. If my slope is very slippery, such that I put a layer of oil or I put a layer of ice such that you can like so slippery, right? What happened to the bicycle wheel? Do you think it will rotate or not? By right, it should not rotate, because if it's so slippery, it will just glide down like that. right? So only if it is rough enough, my bicycle will then can start to rotate downwards, right? Yeah, so that's why in this case, you need to know that only with friction, then okay, so for friction, right, over here, what it does is that it will, oh my god, what did I do? Okay, so for this case, for friction is that they actually oppose motion. Yeah, because if I have an engine force that pedal the bicycle this direction, the engine force will now experience a resistive force, which is the friction that go against it. But then for the front wheel, what are the forces present? You no more engine force, right? Because it is not linked to the bicycle chain. That's why the front wheel, you only have one force, which is the friction. And based on what I just told you that if my surface is super smooth, my bicycle won't even rotate, it will just glide down. That's why over here, in order to make the wheel to rotate, it will be friction, then can rotate it, because I told you, right, only with friction, my wheel then can rotate. And in order for my bicycle to drive towards the left, that means my friction has to be this way to rotate the wheel. So take note, okay, this friction here is to rotate the wheel. As compared to this friction here is to oppose the motion. Yeah, that's why in order for your wheel to rotate so that your bicycle can drive forward, friction has to be towards the right to rotate the wheel such that your bicycle can go forward. Yeah, that's why the answer is opposite. But if you're very confused, right, what you can do is you just study one. You study engine powered wheel. Because engine power is easier to understand. If you have a force, friction just oppose motion. You just go opposite direction. So once you know engine powered wheel, if there is a free moving wheel, right, you just choose opposite answer long, done. That's it. Confirm one. Free moving wheel and engine powered wheel, the friction direction confirm it is directly opposite. Yeah, so if you really like don't understand what I say, you can use this way to study. Let me just opposite answer. Come, let me test you one more. See whether you all understand what I've been teaching so far. So now, if example, I have a slope over here and I put a wooden toy car. Can you follow me and draw out this toy car? Okay, so over here, I have a wooden toy car. So you all know, right? Wooden toy car won't have any engine. So this time around, this is actually free moving wheel. So for the both of their free moving wheels, can you now label what is the direction of friction? You give it a try. Yep, label the direction of friction for both wheels. Yep, label it now. Yeah. By right, if you put a wooden toy car on the ramp, which way do you think the toy car will move? It will go down the ramp, right? Because I don't have engine, so it will naturally go down the ramp, right? Because of gravity. So now what's the direction of the friction? So what's the answer? So come people, come, let's vote. Do you think is it up slope or down slope? Which way is it? Can you point with your fingers? Up slope or down slope? Okay. Then the rest of you? Okay, can. I got the answer. So the rest of you not sure, is it? Okay, so the correct answer is the majority. Yeah, you are correct. It is up slope. Why? Come, let me explain it to you. Because for free moving wheel, remember, what is the force that is present? The force present is only friction. So if I were to have a very smooth surface, like oily surface, by right, do you think the wheel will even rotate or not? The wheel won't rotate, right? Because too oily, it will just glide down. That's why you need friction to rotate the wheel. So friction is to rotate the wheel. That they mentioned here already. What? Friction is to rotate the wheel. That's why for the vehicle to come down, the friction should point this way so that it can rotate the wheel to let the toy car come down. Yeah, that's why friction will be this direction. Hello, like that. Done. Okay, so I shall move on. What's next? Okay, so before I move on, next thing is can I ask you all another question? For this topic you all learned before, I don't want to be the one keep teaching. I ask you all instead lah, cause you already know. Then I can see like how much you all know, then I know how much more to explain in detail, or can I just move on? Okay, so now if I were to give you another scenario, not linked to fiction, okay? Nothing to do with fiction. Just a random, okay, I just leave it here first, but in case you need copy. Okay, so if I were to have maybe a heavy and light object, I let go at the same time. So two object, heavy and light, I let go at the same time. If it's like in the air over here, by common sense, I think you know how the speed is, right? So heavy versus light object, which one will drop down faster? Heavy, right? Okay, so this is when got air. So now if I do it in a sealed environment where I suck out the air to make it to become vacuum, same thing, still heavy and light. Which one will drop down faster?
Same.
So what is it? Very good. The answer is same. Very good. Good that you all know it. That's good. That's good. Okay, so I'll just elaborate a little bit in case those online y'all didn't manage to answer correctly. So in this case, it would be same speed when it is in absence of air resistance. So take note, absence of air resistance means it is in vacuum. So can you see that the graph, you only have one graph? So heavy and light object both fall down at the same speed. Why? The reason is because, what's the formula for speed? You learned it before in primary school, right? It is distance over time. Do you realize that the formula here don't have mass? So mass actually doesn't affect speed, but mass will affect kinetic energy. But I'm not asking you kinetic energy. I was asking you which one fall faster, right? Which is speed. So that's why this time round it is heavy and light object. They will fall with the same at the same timing. So that's why which one fall faster? The answer is the same. This one by right, your teacher should have shown you all this very famous video about the vacuum chamber and bowling ball feather one. Should have seen before, right? Who never even seen before? Then I'll be a bit surprised. Anybody didn't see before this like bowling ball and the feather dropping down one? You've seen before, right? So in that video, they drop down at the same time, Yeah, so that's why, vacuum, heavy and light object fall at the same time. But if got air over here, then do you see? In the presence of air resistance, if got air, then the speed of falling will be different already. Because this one depends on the air resistance. So you need to know that generally is that this time round, the mass affects your graph. So what's happening is that because you need to know that factors affecting air resistance. Okay, come. This one you should have learned before. What are the two factors affecting air resistance? So what thing increase can cause air resistance to increase? One of it is here, very obvious. Speed, correct. One more factor? Yes, surface area. That's why usually for this question, they always have this parachute thing, right? Yeah, so these two factors affect air resistance. So as you can see at the start, it's because object is falling due to gravity. That's why actually the acceleration here, which is the gradient, is actually your G value. So depending on your school, 10 or 9.81, you follow your school's version. Yep. So then for this object at the start, it is really same thing also. At the start, it's the same. Yeah, but the thing is that as time passes, what happens is that because of gravity pull, it makes you accelerate. And when your speed increases, your air resistance increases. That's why here, the air resistance will keep increasing and increasing. Yeah, so that's why at the start, maybe it's only weight. Then the next moment, it would be weight plus a bit of air resistance. Then later, your air resistance can increase and increase and increase until when? Increase until this part here. What is this section called? What's the name? Terminal velocity. Yeah, so terminal velocity is when your acceleration is zero already. Why? Because once you reach terminal velocity is when your weight is equal to your air resistance. So when weight is equal to air resistance, means resultant force is zero. Then F equals to ma. If F is zero, that means A will be zero. Yeah, that's why terminal velocity is when you stop increasing already. Because once your speed stop increasing, means your air resistance cannot increase anymore. That's why your air resistance will only increase until to the point where it's equal to the weight. And then if you stop speeding up, your speed don't change, means your air resistance won't change. That's why max is only until same as weight. Unless you open parachute. If you open parachute, then of course the air resistance will be bigger. Done. Okay, so I shall move on. Next will be, let me see. I jump a little bit first. I know that there is the scale vector drawing. That one is like another section. I go through it later. Let me just finish up all this kind of like calculation kind of questions. Okay, so let's take a look at this part over here. So need to know the common graph drawing. Oh yeah, so for the graph drawing over here, right? As you can see, if your ball is thrown up into the air, then come back into your hands, displacement wise makes sense, right? So for velocity, how come it is this way? Because you need to know that when you first throw up into the air, your speed is very high because your hand push it up, right? So if your hand push it up, it will be maximum speed. That's why can you see at the start, you start with a maximum speed. But as you reach the highest point, like as the ball reach the highest point, do you realize that at this point here, your speed is 0, right? That's why you see it reached 0. So if upward is positive, this time around downward, it will be negative. So that's why you see as it comes down, it becomes negative. Now I have another question for you. Okay, so we said that at the start, your hand push, maximum speed. When you come down, because of gravitational acceleration, you keep on accelerate. So if you keep accelerating, you're becoming faster and faster and faster, right? That's why when you come down, also very fast. And now I have another question for you. If I don't ask you speed, I ask you acceleration. So what is the acceleration as you throw up? So this time round, it will be fast, right? Because if you throw it up, it will be fast, right? So that's why it will be like a maximum. Okay, then now, if you were to reach the top part over here, what happened to the acceleration actually? Okay, wait, let me just, I think, let me just remove this. Okay, yeah, like that. So what is the acceleration at this point over here when the object is stationary? Do you all know? Not 0.
Minus
Surprisingly,
10.
right? Yes, it's actually -10, which is your G value. Okay, let me write as G instead. Why? The reason is because as long as this is one of the major misconception among students, okay? So now that I emphasize to you, take note, okay? Yeah, this is a very common mistake. Is that a lot of students think that, oh, I'm not moving, not moving means 0 acceleration. But that's not true. As long as you're on Earth, you are subjected to the gravitational acceleration, which is your G value. That's why at this point, your acceleration is the G value. And anyways, if you look at the A value, right? Isn't A equals to V minus U over T? So it's like maybe the V here is 0. But the U at the start is not 0, right? So if your U is not 0 and then got a time period that it happened, then it won't be 0 anymore, you get what I mean? Because U got number, T also got number, so your A won't be 0 anymore. So just take note that the A value here should be -10. That's why you see over here, throughout the whole process, the A value is this, which is your -10. Can you label it? So take note, even no matter how the speed changes, the A is still equals to G. Clear? So don't make the mistake of thinking that speed 0 means acceleration 0. Okay, then next part over here, if the ball you let go, then after that it bounce onto the floor, then come up. So for displacement wise, usually we will take the first direction you travel as the positive direction. That's why it will be downward, it will be positive. So if downward is positive, then when you come up, it will become negative. Then in this case, when you were to draw the velocity time graph, you should know, right, as you come down, because gravity keep pulling you down, you will accelerate, right? So if you keep on accelerate, that means your speed will go up. And if you were to look at this part of the gradient, remember in the topic of kinematics, gradient tells you the acceleration, right? And since this time round object is falling freely, if it's in vacuum so by right, it should be the value of G. Yep, so the gradient here, it will be G, which is 10. Then this time around, why got this vertical line is because there's a sharp change in the direction. From downward become upward. That's why from downward become upward. But then when you're at the floor, you bounce up very fast. That's why it should be a super big negative value to say that it's very, very fast in the opposite direction. Yep, and since it's constant value, that's why you see here, it will be constant at 10. So can you label it? So just remember, okay, that object, when you let them travel, no matter how the speed change, the A will always be equal to G. Clear? Okay, so yeah, like that. Then let's continue on to the next part here on terminal velocity. So over here, I don't want to go through any more further. Just wanted to emphasize to you that actually this part over here is like an answering technique lah. Okay, so that means this is like the model template answer. So whenever question asking you to explain the motion of the object, key point to take note would be number one, in the topic of kinematics, you all did learn before. Whenever question asks you to write motion, you need to include two key points. What are the two key points that you need to include? Whenever they ask you for motion, what do you need to include in your answer? Okay. So do you all know what to include whenever question asks you on motion, even for kinematics question? Okay, so since y'all don't know, then y'all learn from here, okay? You write down, So mainly when they ask you for motion, you need to include both the speed and the acceleration. Because for speed means that you're moving, right? Isn't it motion? Then when object is accelerating, isn't that motion? Yeah, so that's why once you got speed and acceleration, that's motion. Yeah, so that's why you look at the answer here, you see every paragraph will have velocity, acceleration. Over here also, that's velocity, acceleration. Can you highlight it? Yeah, highlight it. Can you see velocity, acceleration? So deceleration means speed decreasing. Okay, then next thing to take note is that when they want you to explain, if they say in terms of forces, just need to make sure that whenever you talk about the forces, right, include the direction. Because do you see that you see over here? They will say like upward air resistance, downward weight. So actually for all of them, you should include the direction. This one they miss out. I will just add it in. But this one, the direction not quite important because the focus is factors affecting air resistance. But of course, you can standardize your writing. Whenever got force, you just include the direction. Yeah, so you see the answer is always must identify the force, what direction. Then downward, then resultant force. Then upward, air resistance. Downward, weight. Yeah, so take note, okay? Always include the direction of the forces. By the way, the answering technique here a bit incomplete because over here is that when he start to fall. But at the point when he haven't fall yet, which is this point over here, when he starts from rest, then how do you write it? So let's add it in, okay? So when you start from rest, how you write it would be that you need to mention that the air resistance at the start is zero, right? Because zero speed means zero air resistance. Can you add it in? Because the answering technique, they miss out the first part. They only start off with the front part of the graph. They never start from the origin. So I'm going to write down for you how to write a complete answer if it's at the start. So if air resistance is equal to zero, that means your resultant force will only be the weight, right? Because don't have opposing force yet. Then next is you link it to the formula of M equals to NA. If there is a resultant force, means there will be acceleration. Then done. So this would be for the first point. Then second point, third point, fourth point, and so on. Okay, so I shall move on. Everyone done noting down, right? Okay, so now I shall go back to the scaled vector diagram, which I skipped just now. Oh wait, before I move on to scaled vector diagram, let's take a look at question 12. Just now we did halfway. I changed already. If you're not done, you take a screenshot bar. I'm moving on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, so for question number 12 just now, we completed part C, right? So let's take a look at part A and B over here. So they said that a large plastic ball is dropped vertically downwards from the top of a tall building. And figure 12.1 shows the velocity time graph for the falling ball until it hits the ground. So part A, they ask you to estimate the change in displacement of the ball. Okay, I do not know whether is it clear enough on your side, but the graph look like this. Like that, go up, then go horizontal, then come down here. Can see, you know, there's a vertical line here. Can you see? So take note, there's a vertical line here. Okay, so now for part A, if they ask you what is the change in displacement of the ball, how do you find displacement in a VT graph? You learned before in the topic of kinematics, right? So how to calculate? Correct. So can you just write it down at the side? Yeah, just find the area under graph. I leave it to you. You at home slowly press calculator and calculate, can? I'll just move on lah. You just write down the hints will do. Okay, then moving on. Done writing down the hints. Moving on, part B. Use Newton's laws of motion to explain why the ball accelerate at first, then reach terminal velocity. So right now, can you flip your notes and tell me which page can you find the answer from? So which page can you find the answer from? Which page number? No, not page 3. So you see, whenever I give you a hint, whenever question asks you to explain, this will actually hint you to use the answering technique. Which page can you find the answering technique? Correct, it will be on page 6. Hello, write it down. Yeah, so you do from the beginning. So remember just now I gave you the extra point about the ball starts from rest. So you copy from the annotations about the start from rest. Okay, then you continue to finish it up, by copying page 6. So you choose the correct paragraph to copy. So the first paragraph you should write, it will be the handwritten one, the speed 0 one. Then you continue write the rest. I leave it to you to own self copy down. At home can cost 3 marks, then very long. You write at home lah. This time around, it's just copying. Should be able to do it. Done writing down the hints? Done copying the hints, right? So don't need write everything. You choose the correct parts to answer, okay? So that will be the part that you decide lah. Then later, at the end of the lesson, I'll give you the answer key. You can see whether you identify the correct paragraph to copy or not. Okay, so done for this part. Next, let's move on to the scaled vector diagram, which I skipped just now. Can you all flip to this page over here? Scaled vector diagram. Okay, so for scaled vector diagram, key point to take note is the question type. So you don't just study the method. Yeah, this one teacher also will teach you before, right? Triangle law, parallelogram law. Yeah, but the thing is that when you look at the question won't tell you what, use parallelogram law or use triangle law. What question tell you is the question type. So need to recognize the question type so that you know how to solve it. Yeah, so mainly there are like these two question type is that whether the object is it at equilibrium or is the object moving. Okay, so what does it mean by equilibrium? Based on what we have learned in this topic of dynamics, equilibrium means that the forces are equal. So if the forces are equal, that's why you see resultant force is 0. And when resultant force is 0, isn't it your Newton's first law? I shortcut can N1L. That means Newton's first law. And what is Newton's first law? So if the object is at rest, what happened to the object? So what's Newton's first law? Object at rest will remain at rest. So Newton's first law is just being the same. Then if it's object that is moving, then what happens? So what happened to object moving? Yes, correct. Yeah, so object moving will continue moving. And some more at same speed, some more. Okay, let me write down at constant speed. Yeah, so once you see the question say that it is traveling at constant speed, or if you read the question, they say stationary object, right? And then immediately you should use this technique, which is you must make sure that your lines will keep going in loops. Such that you cannot draw a resultant line. Something like that, like maybe you got weight, then got another force, then another force like that. So do you realize the arrow just keep going in loops? There's no end and start. So if there's no start and end, means you cannot draw the resultant line. Yeah, so this is how you solve it when you see the question say constant speed or stationary. Okay, but then if they say that the object is moving with non-zero resultant force, this means that you will have an acceleration, right? Because only if you got acceleration, you then got force, right? Because if you sub A as a value, then your F will be a value. That means if your A is not 0, so this moving object likely it will be either speeding up. Yeah, because speeding up means acceleration. Or it might be slowing down. Because slowing down means deceleration. As I mentioned here that A may not be 0. That means it can be positive or negative. When A is positive, it is speeding up. When A is negative, it is slowing down. Okay, so once you see that, the speed changing, right? Then take note, you can draw a resultant line. So usually there will be a start point and end point. They just link from start to end. Then you draw a double arrowhead line. Okay, so the line with double arrowhead I'm referring to is this line. Yeah, you can draw a resultant line. Yeah, so once you identify the question type, then now you know, how you solve it. Do you draw them going in loops, or do you have a start and end to draw a resultant line? So you see, recognize by question type. Then now you then need to know how to draw. So I'll recommend that between triangle law and parallelogram law, try to use triangle law. Because triangle law, it can help you to save time. Because how many lines are you drawing? You're only drawing 3 lines, right, for a triangle. As compared to parallelogram, how many lines are you drawing for parallelogram? 1, 2, 3, 4, 5. You draw 5 lines. The more lines you draw, the more waste time it is, right? Because like exam time tight. Yeah, why you want to spend so much more time to draw? And more lines means more inaccuracy also. That's why recommendation is draw triangle law so that you can save time and be more accurate. And one more thing, right, is that if you have like a lot of forces, then like 2 or more forces, right, you can use triangle law. But if you got 2 or more forces, right, you cannot use parallelogram law because parallelogram law is only for 2 forces. Then you just, you duplicate the lines, then here you duplicate the lines. So that's why parallelogram law you cannot use all the time. But triangle law you can use for any scenario, no matter how many quantities there are. Yeah, that's why triangle law is always the best. Save time, higher accuracy, and can be for any number of forces. Okay, so what is triangle law? Triangle law, it would be about the shifting of the lines such that usually when I teach, right, I call it as the monster walking method. You know, like you play game and got like those cute monster walk here and there, right? Yeah, so you just imagine if I have this cute little monster over here that stands here, then he will be thinking, oh, you draw the arrow like that, then he'll be, which way do I walk? Should I walk up or should I walk down? Then you'll be like, oh no, headache, don't know which way to walk. So what you need to do is you need to rearrange the lines. So you need to rearrange such that the monster know how to walk. So maybe this line has shift up here. So you see the monster walk up, then walk down. So then the monster know how to walk already. So over here, yay, he knows how to walk. Yeah, because he walk up, then walk down. So the start point is on the left, then the end point is on the right. So you connect start to end, this will be the resultant. Yeah, so take note, okay? It's not like, I see this diagram here. How to draw triangle law? Then like that, triangle. No, it's not as simple as, I just form a triangle anyhow. No. It must be, you must make sure such that the monster has a clear path to walk. So if you don't want to shift the bottom line up, another way is, the bottom line, you keep it the same, right? The top one, you shift down. So do you realize your resultant is still the same? It is still horizontally towards the right. And so must always rearrange the lines such that this cute little monster knows how to walk in the game. Okay, then next is, whenever you write the scale, recommended is 1 cm is to something Newton. But if you want to write 1 Newton is to something cm, also can lah, just that the recommendation is 1 cm. Okay, that but must be 1. You cannot write 2 cm is to 4 Newton. Cannot. One of them must be 1. Either 1 cm or 1 Newton. And then next is, once you've done drawing, usually teacher sometimes can mark you down, right? Why? Because we have a checklist. So follow the checklist, okay? So once you're done drawing, you follow the checklist. Do you have everything? Number 1, do you have the scale or not? Do you write down 1 cm is to how many Newton? Number 2, do you have the magnitude? Because this is a vector diagram. Vector means that you will have both magnitude and direction. Yeah, so that's why in this case, your magnitude would be, you need to label every line how many Newton. Don't label the cm. Cm is just for you yourself to know, okay, how long should I draw? But teacher is interested in the physical quantities. They are only interested in the physics quantity, like the Newton. That's why label the Newton, not the cm. Clear? Okay, then third, it would be vector, means that it has both magnitude and direction. Direction will be your arrowhead. So you just check whether do you have the arrowhead. You follow what your class teacher say, but if your teacher say draw the arrow in the middle, you draw in the middle. If your teacher say draw at the end, you draw at the end. Both are acceptable, actually. Then lastly, it will be the question. Did they tell you like how many degree? So if the question got mentioned the angle, you need to include it inside. And then maybe if the question say, can you find out what is the angle of the resultant force? So if question asks you for answer, right, then maybe I say, my angle is 40. Can you show it in your drawing? Like, where did you measure that 40 from? Yeah, so that means both the question's angle and your answer's angle must all be in the diagram. So that teacher know that where you measure from. Okay? Yeah, so remember, whenever you do scaled vector diagram, always check if you have all these 4 key points. Done. Okay, since parallelogram law is not recommended, I will skip parallelogram law. Okay, so over here it's just an elaboration. Like, for example, you see, if they say that the object is in equilibrium, what did I say? Remember here? Okay, equilibrium means you cannot draw resultant line. They will keep going in loops. That's why you see the line, you got the downward line, and then you got the point to the right line, and then point to the left, the line. Yeah, so take note, if the question show you point top right, you cannot change to become point bottom right. If the question point top right, you must keep it to be the same direction. You cannot rotate it. Clear? Yeah, so like example, weight is downwards, can only be downwards. You cannot make it become horizontal. You must follow the direction given in the question. Okay, then so all this you can just read it up on your own. Yep, that's all then for the topic on dynamics. Okay, so for this field vector diagram part, let's try out a question. Can we try out question number 3 now? Yeah, can you do MCQ question number 3 now? Do now. Okay, then I shall give you all a short toilet break first before I continue on with the next half. Once you are done with the MCQ, you can go for a break. Then we'll resume in about 5 minutes. So let's resume again at 3:15 p.m. So yeah, toilet break now. Any of you who have any questions, you can use this toilet break now to clarify with me. Yeah, so you can ask me questions if you anything unsure. So how physical students, any questions? Online students, any questions? Then you just link such that the monster has a clear path to walk. Also can go up, go down, and all. Yeah, just link all the lines together. So any of you, if you need to go toilet, make sure you go now. So once 3:15, I will resume with lesson already, and I'll review the answer for question 3. Let me go and pick up my bottle.
Brother, what it is, brother? Brother, any
Hey, why? Oh, you can't find it. Oh,
you know one, yeah.
So for oral question, you are asking, how can you ensure that your interpretation for your graph is correct? Like for example, displacement time graph, do you consider the gradient, whether is it positive or negative, then draw for the velocity time graph? Yeah, correct. Because the gradient of a displacement time graph tells you the velocity. And you need to know if the gradient is positive or negative first. Because if the gradient is positive, means your velocity is positive. So for your VT graph, you need to draw above the x-axis for positive velocity. But if your gradient is negative, means you will have a negative velocity. That's why you should draw the graph below the x-axis of your VT graph. So the answer is yes. Okay, people, this is 3:15. Let's come back for lesson. Can you all be seated, please? Thank you. Yeah. Go back to your seats. Okay, so for question number 3, you all managed to complete it already, right? So what was your answer for question number 3?
Yeah, I'll take it.
What did you get? What's the answer? Answer is A. Correct. Very good. Answer is A. Why? Because remember the word equilibrium. Equilibrium means the arrow will just keep going in circles. Okay, so this is the key point. You can highlight it also if you got it wrong. And equilibrium means that you keep going in loops or circles. And so that's why the answer will be A. Done. And the arrow must be of correct direction, of course, right? Like weight must be downwards. Then the tension here, can you see, is like this direction. And this tension also is in this direction. And also, it must be the pointing in the correct direction. Because I told you, you cannot rotate. Okay, you cannot rotate the line. Okay, so let's move on to the next chapter. So for the next chapter, it would be turning effects of forces. So for turning effects of forces, the front part over here, all these you already know from the school notes. So I don't want to go through anymore. Okay, so the next part here will be the formula. So need to know that for moments, it will be F times D. And take note that for your distance over here, it must be perpendicular. As well as this distance must always be from the pivot to the force. Write down. Are you copying? Okay, then next, the principle of movements over here is more for calculation, where you need to know that sum of clockwise equals to sum of anti-clockwise, there, like that. So usually when you do calculation, I'll recommend you to present your answer properly. You write it as this way. Taking moments about which point, comma, then you write down the principle of moments, which is sum of clockwise equal to sum of anti-clockwise moments. Then after that, you sub in the working. Because depending on the mark allocation, if it's 2 marks, right, okay lah, the template here, this part here, the first 2 lines, they won't count as 1 mark. But if it's 3 marks, right, then this part here can be 1 mark, you know. Yeah, so that's why try to always present your answer properly. Okay, so let's give it a try to see whether you understand this chapter so far. Okay, so right now, can you do question number 5 and 6 now? Yeah, do question number 5 and 6 now. So key points to take note is that distance must always be perpendicular and from pivot to the force. Do now, do now. Do question 5 and 6 now. Question 5 and 6, the MCQ. Yeah, so the snacks that y'all got, this is actually not only the only perks for overmark students. So for overmark students, we sometimes we will even order like bubble tea, and sometimes we will even order like downstairs like acai affair and all for students. Yeah. So it's just one of the perks. Yeah. So which schools are y'all from? It seems like y'all like know each other. Oreo Valley. By chance are you like Isaac's friend or not? Isaac, no, Isaac. Because he was like telling me that he's like he will have like one whole gang attending the lesson. Yeah, so I thought that maybe you're his friends.
I don't know, it's too many Isaacs.
It's okay. They'll speak very fast, Isaac.
3G Isaac is wait 3 oh no 3
This is the
Isaac
Isaac.
Yeah, no, Isaac I'm referring to is same age as you. Yeah.
Probably lah I study very fast.
Oh, the one that always hold basketball one.
Oh, the 3D guy, the 3D guy. Oh, yeah.
So who recommended your like to join this session today? Oh, your mom. Oh.
Oh, he bring up basketball to play. They do every day.
Question 5 and 6, do both. Wait, you can square root 1.
Find the distance, what? What is the people?
Must be right.
Okay, so should be more or less done with question 5 at least. So for those of you who are done, what's your answer for question number 5? What do you get? Yes, correct. The answer is D. Okay, so let me go through it, okay, in case you got it wrong. Okay, so for this question here, what you need to do is, for each of the force, you only need to find the perpendicular distance. So for example, if your force is over here, vertical, what is perpendicular? Perpendicular will be horizontal, right? So the distance must always be from where to where? It must be from the pivot to the force. So the horizontal distance must be from the, can you see the pivot here? So you take note that the distance don't need to touch the pivot. You can actually dot it out. So that means like my pivot here, I can dot, 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 dot. So this would be my perpendicular distance, which is 2 meters. So you see, now this is perpendicular. Can? Okay, then the next one, you have this 20 Newton here, right? So same thing. If your force is horizontal, perpendicular means it must be vertical, correct? And then again, same thing. It must be always from where to where? It must always be from pivot to the force. So if the pivot is here, the force is here, that means this would be your perpendicular distance. Since they mentioned to you that this whole thing is 3 plus 1, right? 4 meters. And on top is 2 meters. That means below here will be 2 meters. So this would be its corresponding force and distance. Then next, you have one more over here, right? Which is 10 Newton. If your force is horizontal, perpendicular means it must be vertical. So that's why the vertical distance must be from the pivot to the force. You don't want to extend out pivot also can. You want to extend out force also can. So you see, this time round, the perpendicular, which is vertical, it must be from the pivot to the force. And how long is this line? This line is that they shown it over here, which is actually this 3 meter here. Can? Then next is you need to identify them. Are they clockwise or anti-clockwise? Okay, so for this force over here, if you pull it up, can you see that this whole thing will rotate this direction? If you pull it upwards, that means this is turning clockwise direction. So this is clockwise moment, CW. Then now, if you pull with the pink one, do you realize it's also going this direction? If you pull with the pink color force, so this is also clockwise moment. But then the orange one will go opposite direction. So the orange one will be anti-clockwise movement. Then you use the formula, the sum of clockwise movement equals to sum of anti-clockwise movement. You give it a try, but you see whether can you get it. Then those who are not done with the question number 6, can you quickly finish it up? Then I'll go through soon. If you are still super lost, right, I'm going to write out the working for you, okay? You can copy down the working. So you just type in the values as per the color code. Then for those of you who are super fast, once you are done, you can do question number 4. Question number 4, I'll leave it as homework for you all. Yeah, so if you are done with 6, you can move on to question 4. You can also do question 12, just like I told you all, right? Question 12, I give you all the hint, then I say that you all can complete as homework. Yeah, so once you are done with question 6, you can do 4 and 12. Just wondering, which school are you all from? Yeah, ACSI. Oh. Okay, I shall move on already. Should be done by now for question 6. If you still can't answer, means likely you are stuck already. So, what's the answer, class? What do you all get? For those of you who got it. Yeah, answer is C. Okay, so if you can't answer, good that you come here today so that I'm going through with you now. Okay, so if you can't answer it, you listen to my explanation now. But if you can get question 6 correct, right, then don't need listen to me anymore. So meanwhile, you can go and do your question number 4 and question number 12. This will be your homework. Okay? So those of you who got this question wrong, listen up. I'm going through for you now. Okay, so again, same thing. We always go and identify the perpendicular. So if your force were to be here, if your force is horizontal, what is perpendicular? Perpendicular will be vertical, correct? Yeah, so that's why if your force is horizontal, what's the perpendicular distance? So same thing, distance must always be from the pivot to the force. But you cannot draw slanted, like that wrong. Because the distance must always be perpendicular. So if your force is horizontal, distance must be vertical. That means I can dot out. So this would be the perpendicular distance. Okay? Yep. Then this time around, But if you label like that, how I know what is the cm, right? So what you can do is, you need a bit of math really, which is here. Can you see that if I have the center, I touch here, right? And then if I do it vertically, do you see that there's a triangle here? Okay, so now let me draw out the big triangle. Yep. So in this case, for this drawing here, the diagonal, isn't it the radius of the circle? So what's the radius of the circle based on what is given here? What's the radius? It is 50 cm, right? So let's write down in SI only because they do in Newton. So this will be 0.5 meter for the radius. Can you see? I'm trying to mimic this small triangle. I enlarge it. So this triangle is this triangle. Okay? And then next is for the vertical part. How do I know how much is this vertical part? So do you see that actually from the center all the way to the bottom, you see from the center all the way to the bottom, isn't this the radius? So if this whole part is the radius, let me just mimic out. If this is the radius, and we said that the radius is 0.5 meters, this part of the box, you know how much, right? That means this part here is 10 cm, which is 0.1 meter. Do you know what's the height of this triangle now? So what's the height? 0.4. So let's label it. Over here, this is actually 0.4 meter. Yep, so then now with this information, you see, you got the distance radio, 0.4. So let's write it down, 0.4 meter. Okay. Okay, then continue on. So for this force, this will be the perpendicular distance. And what did they ask? They just ask you for the force to overcome the weight. Okay, so now let's also include the weight. Weight is always from the optical center. So I'm going to draw now. For this weight, right, it will go through the center. Yep, weight. So for the weight, it will be this part here. And since weight is vertical, what's the direction of your distance? So if weight is vertical, perpendicular will be which direction? It will be horizontal, right? So that's why this time round, the horizontal distance must always be from the pivot, which is here, to the force. So this would be the distance. Isn't this the distance, this part here? Your bottom part of the triangle. Then now you can find, right? If you got 0.5, 0.4, what's the distance here? You can use Pythagoras, correct? So you use Pythagoras. In the end, when you solve, what's the answer? 0.3. Or you can recognize, I don't know whether you all recognize, only this number is very unique. It's the 3, 4, and 5. 3, 4, 5. Yeah, so only this 1, 2, 3 cannot, okay? Only 3, 4, 5. Yeah, so that's why 3, 4, 5. So now we know that this distance here, it would be 0.3 meter. And what's your weight? They mentioned here, it is 100 Newton. Then now, you just make them to be equal to each other because it's like, this force is causing the ball to rotate this direction, right? Can you see the force when you push it? It will cause the ball to turn anti-clockwise movements. But then the weight will cause it such that it will drop back down. So the weight will cause it to drop back down, right? That's why the weight, it will actually be clockwise. That's why you just let the sum of clockwise moments equal to the sum of anti-clockwise moments. Done. You know how to solve it? You give it a try. You see whether can you get the correct answer. Answer is C. Okay, so in case any of you are super lost still, what you just need to do is you just need to sub in the F times D. Yep, so that's why for the clockwise, I already mentioned to you is due to the weight. So just F times D. Then for the anti-clockwise, it will also be F times D. Yep, then just solve for F. The answer should be C. Okay, everyone should be more or less done by now. So I shall move on, okay? If you still not done, if you are still copying, you can take a screenshot of the answer. Yeah, you can take a photo, then I will be moving on in 3 seconds. Okay, so let's move on now to the back to the note because I haven't finished the notes yet. I'm not very sure which page am I at. Let me see. Yeah, I'm somewhere here. Okay, so just now I went through until here, right? So then next would be the next section here. So can you all flip to page 7? So need to know that whenever question says that objects are at equilibrium, key point to take note is that resultant force is 0. Resultant moments is 0. What do they mean? It means that if your resultant force is 0, that means upward force equals to downward force. Yeah, so take note, okay? Sometimes question, right, for topic on moments, don't need to keep using the moments formula one, okay? You see over here? Then you can also use upward force equal downward force, two tension upwards. So TA and TB, yeah, is equal to the two weights. Yeah, like that. So it's not always need to use the moments formula, the what force times distance and force times distance. Don't necessarily need to always use moments formula. You can do just upward force equals downward force. It's easier also, faster. And then resultant moment 0 just refers to clockwise moment equals to anti-clockwise moment. So these are the two methods to solve things. Okay? Yep, so that's why over here they just showing to you that this is how you present your answer. Always identify the pivot. Here. And then which one do you choose as the pivot? So you need to read the question. If the question is asking you, maybe you want to find, like over here, can you see? You want to find TB. Usually you take the other point as the pivot. So take note, the force that you want to find cannot be the pivot. Why? Because if the force you want to find is the pivot, right? That means, example, B, if you take B as the pivot, do you realize if the force at B is vertical, perpendicular distance is horizontal. And if your pivot is also at B, that means there's no horizontal distance. If there's no horizontal distance, that means the moment here is 0, then how you solve for TB? That's why you must make sure that if you want to solve for TB, the moments at TB cannot become 0. That's why you make the other person to become the pivot. So when the other person becomes the pivot, the moments due to TA will become 0 because there is 0 horizontal distance. If your force is here, my pivot also here, can you see? No horizontal distance. Okay, so take note that your pivot must always be opposite. So you see, if you want to solve for TA, you take the other point as the pivot. You take point B as the pivot. Must always take the other person as the pivot. Done. Okay, so for this kind of question, I think you all did a lot of practices in school before. I'll leave it to you to do it on your own. So I'll leave question number 13 as homework for you. It's just mainly using this clockwise equals to anti-clockwise moment and upward equals to downward force. Okay, so you finish up question number 13 as homework. I'll give the answer key at the end of the session. Moving on, next part over here on center of gravity. So center of gravity is the point as if entire weight seems to act on. Now, I have a question for you. Can center of gravity be in somewhere that is hollow? Cannot. Can it be like in the air, hollow? The answer is yes, can. So one example would be maybe like a donut. So if you have a donut, if you want to make sure that it's balanced horizontally, what you should do is you should poke the satay stick through the center. So if you poke it through the center, you can visualize, right? It will be balanced. But if my this donut, donut center is hollow, if I were to poke it here, do you think my donut can remain horizontal or not? It cannot, right? If I poke it at the side, it will like topple down on the other side. Yeah, so that's why it is possible that the CG is in the center, and as long as you provide support through the CG, it will be as if you support the entire donut's weight. That's why it will be able to balance and remain horizontal. So it is possible to be in an empty space. Okay, then next it would be the 3 different type of equilibrium. This one you already know, right? I don't want to repeat anymore because it's just notes, nothing much. I wanted to emphasize to you is this. Yeah, so whenever got explanation question, remember to use the answering technique. Yeah, so how do you phrase your answer? You always mention about the line of action of the weight, whether is it within or outside the base area. Then next is mention about the moment. Is it clockwise or anti-clockwise moment? And then must mention about which point. So do you realize, no matter is it calculation or sentence writing, you must always identify the pivot. Like over here, there do you see it? When you do calculation, You see, must write the pivot. So same for sentence writing also, must always write the pivot. Can, so make it a habit, calculation and sentence writing, both must write the pivot. Okay, then next would be factors affecting stability. This one I think you all should know lah. Yeah, so let's already try out question mark to see how well you all understand. Okay, so right now, can you do MCQ question number 7? Do now. MCQ question number 7. Then for those of you who are fast, I told you, right, the new homework is question number 13. If you are done, you can move on to do question 13. Okay, anyway, this question don't even need much calculation. It's either you know it or you don't know it. Yeah, so I think you should be able to go through the answer now. So what answer do you all choose? Yeah, correct. The answer is C. Okay, so for those of you who got it wrong, you listen up, okay? Okay, so for this question here, what's going on? So you need to know that sand versus oil, sand will have majority of the weight. That's why you see, if you look at this object, where is the midpoint? The midpoint maybe somewhere around here, the original one. So based on this surface here, the midpoint is somewhere here. But then because sand is denser than oil, the CG won't be at the exact center. It will shift towards the side that is a bit heavier. That's why it will shift down a little bit. That's why the original CG should be slightly below the midpoint, which would be position Y. That's why you should start from Y first. So you're left with only C or D. Then next is, if you were to add more sand in, the entire level will shift up, right? So now maybe my entire level end up shift up maybe to maybe like over here. Then again, same thing from the top to the bottom, where's the midpoint? Somewhere maybe around here. Yeah, so that's why in this case, it would be now at position X. Yeah, but that is too low already. Yeah, it's not a bit too extreme. If you got so thick a column of water, how can your CG be so extreme at the bottom? Cannot be, right? So a more logical answer would be is at X, because usually CG is somewhere at the center. But this time around, because you add more weights down, that's why the whole CG gets shifted up. Okay, so the answer is C. Okay, then continue on. So yeah, I think I'm done already for the turning effects of forces topic. Okay, so let's move on next to the topic on energy. Okay, so the front part over here, this one I won't go through anymore because by right all this you all learned it before in school already, all the definition, nothing new. Yep. So just take note that for efficiency over here, it has a formula, and the formula here is not strictly energy, because this time round you can either write it as energy or you can write it as power. But definition wise, you follow energy lah. But just that formula wise, you can actually change it to power. So just be careful. And for the formula here for efficiency, you all know, right, that overall efficiency will definitely be less than 100%. Like example, I pump this amount of fuel into the car. By right, the amount of energy to make it move cannot be more than what I pump in, right? That's why energy cannot exceed 100%. So in order to be less than 100%, it means that you should always sub in smaller number divide by bigger number. So sometimes in exam very confusing. I don't know, is it input, output? Don't know, is it like useful or not useful? When you're not sure, you just put small number, divide by big number. That's it lah, to make your life easier. Yeah, so that you can get less than 100%. Then next is, when do you use energy? When do you use power? You just need to be consistent. If your numerator, you use energy, just make sure that your denominator, you also use energy. If you use power, then make sure both are power. Must be the same quantity, so that the unit can cancel out, like joules and joules cancel out. That's why in the end, efficiency is in terms of percentage. Okay, then next, all these formula, I believe y'all should know by now. I would say that the only one that y'all might not know is, got this formula, man. Okay, so this formula is not new. Actually, you can derive. You can derive from here. Because power, right, they say it's work done. What's work done? Work done is force times distance, correct? And then next is, if you have distance over time, isn't this speed? That's why, can you see? It will be force times speed. So it's not a new formula. You can actually derive it. Yeah, so can you write it down? So just take note, okay? Power can take force times speed also can. Okay, then next is whenever you have calculation question, just to let you know that if question asks you to calculate energy in the gravitational potential store, you can actually use the EK formula to calculate. Why? Because energy can be transferred from one store to another store. That's why to calculate EGP, you can use half mv square. Likewise also, if they were to ask you to calculate EK, you can also use the work done formula also. Because work done is in joules. So maybe the work is to make the object move. That's why if they ask you to find out what's EK, you can use F times D. Also can. Yeah, so these formulas, they are all interusable. Yeah, so like for EGP, you can use work done formula also can. And next, also need to recognize that if question were to say that what is the work done against gravity, this is the formula. Yeah, because if you want to go against gravity, that means you want to gain in your gravitational potential store. Yeah, that's why you can use this formula for work done against the gravity. Okay, that's all that I'll be annotating here. Once you are done copying, I'll move on. Be done by now, right? I move on. Okay, so for the next part over here, it will be the energy stores. So take note that for energy stores, it's not anything also can store. Like you cannot say that, oh, I want to calculate maybe I want to talk about electrical energy. Do you realize over here don't have electrical store? So take note, okay, it's not like anything also can become store. Don't anyhow. Yeah, so stores are only these six. So I write down here only six of them. Okay, no such thing called electrical store. Then I think in lower set you all learned before, right? Like, oh, always lose as heat and sound energy, right? So there's no such thing called sound store also. Then you say that light bulb emit light energy. Also no such thing called light store. Then there's also no such thing called heat store. So heat, you use the word internal store instead. Okay, so internal store means heat. Cannot use the word thermal, just say internal store. Okay, so if it is like, got electricity or like got sound or got light, then how do we phrase it as the answer if I need to mention it? So this is how you phrase it. So for electrical energy or electrical stored, instead you should use the word transferred electrically. Then if it is like energy lost, we will usually use this word called dissipated. So dissipated just means lost to the surroundings. Then if it is the word sound energy, you write it as it is transferred by propagation of sound wave. Then if it's light I think it's not mentioned here. Let me add it in for you. Okay, so for light energy, which is the incorrect one. So the correct way will be by propagation of light waves. So this is how you phrase it if you want to talk about light energy. Then if you want to talk about heat energy, you can use the word internal store. And remember, I just mentioned to you that whenever it is energy loss, we always use the word dissipated. Just try to learn the answering skills for this topic. Lost means dissipated. So this time round can be dissipated due to like work done against friction if you know that it's lost due to friction. Everyone done copying, right?
What does propagation mean?
Propagation means it moves. So it's by the movement of the light wave, by the movement of the sound wave.
Okay.
Okay, I shall move on, should be done by now, right? Okay, so just take note, okay, that in this topic, right, make sure that you use the correct term. If you want to talk about friction, you should use this word, work done against friction. Why? Because work done against friction, it would be for the word work done. That means it is in joules. So for this topic, it is okay to use work done against friction. In this topic, don't use the word friction. Why? Because friction is a force, it's in Newton. Okay, so don't tell me that, like just the word friction itself cannot. Must use the word work done against friction. Once you have the word work done, you will convert it to become joules. Okay, so I shall move on. Right. Okay, so moving on. Next part over here, things to take note of for this chapter is that when you were to do any calculation question, take note that the force and distance now it is not perpendicular. It is moments that is perpendicular. For work done topic, it is parallel instead. Yep. So yep, it's like that. So example, like if your object is you pull it to the right, then your distance must be to the right. Oh. Can you see that the distance and the force, they are parallel to each other? Yeah, so take note, okay, they must be parallel. As compared to moments, it is perpendicular instead. Okay, then next is yep. If displacement of object is zero, means work done is zero. Like for example, if I say that my boss asked me to push this wall, so I push. Wow, I push until muscle ache, sweaty, and all. Then do you think did I do any work? The answer is still no work done, right? Because when my boss come, they will say that, hey, why you never do your work? Why the wall still here? Like never move. Yeah, so that's why if there is no distance move, that means no work done. Okay, then next is for this topic, usually there will be certain way to solve it. So I'll call it as just now it's like answering technique is for open-ended sentence writing. So now if it's calculation, I change it to calculation technique lah. Yep, so for the calculation technique, there are a few of them. Number one is this. So you can go with the total work done. So total work done would be the work done to push the object up plus the work done against friction. And one interesting thing is, do you realize this one, the friction is a plus? You know, normally friction always oppose motion. We always put minus sign, right? But how come here we put a plus sign instead? The reason is because I ask you, if I don't have friction, how much work or how much joules do I need to exert? If don't have friction versus got friction, I will need lesser, right? That's why by right, if don't have friction, my value should be smaller, ma. But if got friction, I need more energy, right? Oh, very hard to push, got a lot of friction. And so with friction, my number should become bigger. That's why it should be a plus sign. So that the number of joules is a bigger number when there is friction. Clear? So take note, okay, that in the topic of this work done and energy, friction, you should plus instead versus the topic on forces. So in the topic of forces, if we were to calculate like resultant force, we will take like force minus friction. So take note that in the topic of forces, we minus is because friction oppose motion. That's why remember, forces is actually a vector quantity, and vector quantity take into account the direction. Since friction is of opposite direction, that's why it's a negative sign. But then for work done, it's a scalar quantity. If it's scalar, scalar don't have negative. And plus, with work done, you need to exert more joules. So more joules is needed in presence of friction. Can. So don't get confused. Different topic, your friction, different sign. In the topic of forces, you minus. In the topic of energy, you plus. You want to copy it down or not? Yeah, so take note. Yeah, you should write it down because this is a part that some students might get confused with the topic on forces. Yeah, so be careful. Okay, so this is calculation technique number one. Calculation technique number two will be you can actually base on energy at the start equals to energy at the end. This is due to the principle of conservation of energy, right? Because energy cannot be like created or destroyed. That means start and end should be same amount. It should be 100%. Another way to solve question will be you base on the amount of energy gain will be the amount of energy loss. Same thing because energy cannot be destroyed or created. So how much you gain will be how much you lose. And so make sure to follow and copy it down. Okay, come, let's take a look at the this part over here. So this time round, if they tell you that, okay, I'm pulling up the box upwards. So if I were to pull the box upwards and I ask you, what is the work done? I think this is quite obvious, right? So if I ask you, what is the work done? So this time round, if I have a pulling force, okay, over here they never show lah. But if I were to have a pulling force, work done will be just force times, what's the distance if I'm pulling the box up? So what's the distance? Is it 5 or is it 3 or is it 4? So if I ask you, what is the work done exerted by this force here on the box? So the answer is F times 3, 4 or 5? 5, correct. Because remember I told you, they must be parallel. So that's why if your force is diagonal, that means your distance must also be parallel. So that's why it should be this distance, which is 5 meters, can? Because they must be parallel. That's why the answer is 5. Okay, so another kind of question they can ask is work done against friction. What is work done against friction? It's just work done of friction. It's just a grammar word because you know friction always go against motion. That's why they use the word against. But it's just work done of friction. That means when you calculate the work done of friction, you just need to sub in the frictional force and the frictional distance. So for this question, they mentioned right that the frictional force is 3 Newton. You sub it in, no? And what is the distance that the friction acts on? The friction will act on the entire surface, right? So if they act on the entire surface, means the entire surface, which is 5 meters, will experience friction. That's why the distance is 5 meters. So that's how you calculate work done against friction. Okay, then next, if they were to ask you gain in GPE, oh wait, actually should phrase it in the updated syllabus way. I should be EGP. Can you phrase it for me to be EGP instead? Yes, so that means energy in the gravitational potential storm. So in this case, for EGP, is also known as work done against gravity. It's over here, there. Work done against gravity. I'm just writing it out again. Because if you go against gravity, means you're lifting it up. So for work done against gravity or EGP, what happened to your H? Do you realize that H they use 3? Because you need to know that EGP is mg. Mg, isn't it here? W equals to mg. So if your mg is vertical, that means your distance used must also be vertical. That's why you should use the vertical distance, which is 3 meters. That's why can you see the H here is 3. So must make sure that it must be same. If your force is downwards, your distance must be downwards. Yeah? So must be same. Yeah, it must be parallel. Done. Okay, so once you are done with all the annotations over here, let's try out some questions to see whether you understand what I've been teaching so far. Can you all do question number 10 and 15? Yeah, do question number 10 and 15 now. By the way, 15, can I be specific? So your question number 15, right? Can you only do 15 B part 2? We'll do lah. Yep, just like that. Yeah, so do question 10 and 15B part 2. By the way, meanwhile you are doing your work, anyone have any questions you want to clarify on? Any parts unsure? Yeah, I think by now you should be done with at least question number 10 already, right? Because question number 10 is like pretty straightforward. Okay, so what's your answer for question number 10 for those of you who managed to solve it? What's the answer? So what's the answer for question 10? No answer? Yeah, answer is A. Correct. Okay, so why is the answer A? So remember, just now I was telling you that if you were to need to know what is the W, which is the work done against friction, then you must make sure that both the force and distance must be parallel, right? So if your frictional force is, how much is the frictional force? Did they mention? Oh, you're supposed to find. Okay, can. Let me do EGP first, like it will be easier. Okay, so for EGP over here, so this time round, to raise it up, that means you need to use the formula MGH, correct? And for M and G, what direction is it? Is it MGW? So this is actually W times H. Since your W is vertical, that means your distance would be vertical also, right? That's why in this case, it would be 500 times 3. You get 1,500. So that's 1,500. Next, for this work done against friction, what you need to do is you have to take into account the total, because based on the answering technique just now, the calculation technique, I mentioned to you, right? One way to do it is energy at the start equals to energy at the end, or total work done. Let me show it to you. Another way to do it is this. Then can you see? Total work done is work done on the object plus work done against friction. So let's write this out, okay? Total is work done plus friction. Okay, so I'm going to write it out. So total work done, it would be the work done that you use to exert the object plus the work done against friction. You follow what your teacher say, okay? If it's open-ended, if your teacher say cannot write WD, you spell out work done, yeah, because some schools don't allow. Yeah, so spell out in full. Okay, so then in this case, what's the work done on the object? It is to raise its height. Yeah, so since you are raising it up, that's why it would be your EGP log, which is your 1,500. Okay, then next is, in this case, what's the total work done? They told you, right? They exert with a force of 400 to pull it up. So the 400 to pull it up includes overcoming the friction, right? Because it's like, pull with 400, that means I'm trying to overcome the friction. That's why the work done here, it will be your F times D. So the diagonal distance here, they said is 5. Then now you just solve for the work done against friction. That's all. Yeah, so 4 times 5 is 2,000. 2,000 is 1,500 plus 500. Done. So answer is 8. So this is the one that I'm saying. Remember, friction for this topic is a plus, not a minus sign. Okay? So whenever you have calculation question, just try to refer to one of the 3 techniques. I already taught you, right? There are 3 different methods to solve it. You try to apply one of the 3 methods. That's why after a while, you can actually realize that there are like standard way to solve things. Like for example, dynamics topic. The standard way to solve it is the L shape. Then if it's turning effects, the second chapter that we did, is always the clockwise equals anti-clockwise plus upward force equals downward force. Then you see for this energy topic, there are 3 possible ways to calculate. Yeah, so just try to remember like, for this chapter, what are the ways to solve it? As long as you use those recommended method, usually you can get the correct answer. Okay, so let's move on next to the question number. Just now I was saying to do question number 15, right? 15, B part 2. Okay, so for this question, let me just give you some hints. Okay, so they said that the figure 15.1 shows you that there is this ball of mass 0.5 kg that is sliding down the incline. And then this time round, it is rough. Rough means later there will be friction. Yep, so then they mentioned here already, rough is because there will be 10.7 joules of work done against friction. And next, the H, it is 7.5 meters. And now the ball leaves B, go up another height. So this is another height again, 13 meters. So for part A, they are just asking you state the principle of conservation of energy. This one you just copy from the notes. So this one should be no problem. So take note, this is very commonly tested. Please go and memorize it. Principle of conservation of energy. By right, you should remember. This one also appeared in Sect 2, right, last year. Yeah, so nothing new. Okay, so B part 1 is easy. It's just the EGP formula. Okay, we look at part 2 over here. Calculate the initial speed at position A. So whenever this is like 2 marks calculation kind, you will actually need to use your calculation technique. So remember, just now I labeled for you 3 calculation technique. Can you go and look through it? Which calculation technique can we use? Hello, can you flip your notes now? So which calculation technique can we use? Which one is it? It was on this page, right? There. So this is one of it. Then after that, I mentioned to you, right? The second one was about the energy at start equals energy at the end. Then after that, there's one more, right? Which is the energy gain equals to the energy loss. So for this question, which one do you think is suitable? Are you at this page? So there is the number 1 here, right? Then number 2, number 3. So how for our this question 15B part 2, which method should we use? Because remember I told you always try to use the calculation technique, then you can solve it. So how, which one? 1, 2, or 3? Can you point your fingers? Which one is it? Not sure. 2. Yeah, correct. Very good. Yep. So it's about the energy at the start equals to the energy at the end. Good. So let's write it out now. Where was I? Yeah. Okay, come. Let's write it in. So this time round, let's write down at the side to remind ourselves. So it will be the calculation technique number 2. Yep. And what's the calculation technique number 2? It would be the energy at the start equals to energy at the end. Hello, follow and write it down. So this is the working. So what is the energy at the start? So they are talking about position A, right? So if the ball is up there, what kind of energy does it have? Can you see? Position A. So what energy does it have? So what energy is it? It's quite obvious, right? The energy at the start. What's the energy at the start? Gravitational potential, correct. Let's write it down. That it should be EGP. Any more energy? Any more energy at the start? Still have what's the another energy that is at the start? Need to read the question carefully. Don't careless. Got one more energy at the start. What is it? Those online, your one you can answer also, okay? Yeah, so what's the energy at the start? Okay, maybe I move on to the next student. I move on to Prish. So Prish, what's the another energy at the start over here? I circled
Kinetic
it.
energy. Kinetic.
Okay, sorry?
Kinetic.
Yes, very good. Kinetic. Because can you see that there is a speed? Yep, so at the start, there is also kinetic store. Okay, then next, what's the energy at the end? So the energy at the end, it would be at position C, right? So at position C, what energy is it? Next, I move on to Giselle online. Yeah, so Giselle, at position C, what energy do you have?
Gravitational potential.
Correct, gravitational potential. And next is they also mention about there is like friction, right? That's why you must mention all that at the end, because you rub and rub and rub, a lot of heat, right? That's why towards the end, you also have work done against friction. Okay, then now can you sub in all the values? Then once you sub in all the values, then can already. Or maybe this part, can I leave it as homework for you? It's just like put in number, press calculator. This kind you can slowly do it at home. So now that during the lesson time, I rather focus and go through like the more important stuff. Press calculator, I think you can do it. Okay, so this is the main gist of the answer. Okay, so moving on to the next page over here, part C. State one assumption for your calculation in part B. So in lower sec, I think you all can tell what is the assumption, right? It's always, we always assume that there is no what thing. What's the assumption? So what's the assumption over here? No air resistance, true. So no air resistance means there will be, in terms of the topic of energy here, how can we change air resistance, which is a force, to become in joules? Work done, correct. So remember just now we had work done against friction. So now you change it to work done against air resistance. This time around we are assuming that there is no work done against air resistance. Yeah, so this is to make it such that it's in joules. Or you can, based on what you learn in the lower sec, like maybe no energy loss as sound. Yeah, no sound energy loss of surrounding. So if you want to write as no energy loss of surrounding, right? How you phrase it, it will be that no energy is, remember this topic, when you want to see the word lost, what is the new keyword that you need to have to replace the word lost? Dissipated, correct. Yeah. So this is how you phrase it based on the new syllabus. So we assume that there is no energy dissipated to the surroundings. But we cannot say as sound energy, right? So now how do we change our phrasing to match the new syllabus? Correct. By propagation of sound waves. Yeah, so this is how you phrase your answer. And then usually you not only lost as sound, you also lost as heat, correct? So how do you mention that you lost as heat wave? Yeah, so you can mention that and no energy is transferred to the, so what's heat called in this topic? Internal store, correct. But then for the internal store of the surrounding, right, this part here, another way to write it is, you can also say that no energy is another way to write. You can still use dissipated. So it's dissipated to the surroundings by propagation of infrared radiation. Okay, so there's two ways of phrasing. Yeah, but if you just say internal store of surrounding is shorter, as you can see, this is a bit longer. In case you're wondering why I write too many, okay, just to let you know, I highlight for you. This part here, you can replace it with this part here. They are the same thing. By the way, for just now, the energy notes, I only left with one last section, which is about the renewable and non-renewable energy. So that part, I'll just leave it to you to study on your own, because it's just facts. Okay, so let's now, I start from the first page of the worksheet. Let's just check through and make sure that questions that are tougher, we do it together in class. Then the easier ones, I'll leave it to you as well. To be done by now, right? I move on. Anyways, no worries. Whenever you can't catch up, I will give the answer key at the end of the session. So you can just check the answer key. Yep, we will get the answer from there. Okay, so let me just start off the MCQ first. So for the MCQ just now, question 1 we completed, right? Question 2 also done. Question 3 also done. Okay, settled. Question 4, just now I already told you that is homework. So after you are done, you just check the answer key for the answer. Question 5 and 6 and 7 we completed, right? So okay, can. Let me see. Question 8, is it difficult or not? Question 8, still okay lah. Okay, I give you a bit of, let's go through a little bit. Okay, so they said that Joseph jumped into the air from a springboard and then falls into the swimming pool. So first is, this time round, because it's about kinetic store, that means we need to check its speed. So if you were to jump into the air from a springboard, so what would happen to the speed? So next I move on to online of Estelle. So Estelle, what happened to the speed as the person jumped up?
Increase.
Yeah, correct. The speed will decrease. Can everyone label it? The speed will decrease. Then later, he falls into a swimming pool. Next, I move on to online Chloe. So Chloe, what happened to the speed as he comes down?
Increase.
Yes, correct. Very good. Then after that, you just choose the appropriate answer. Quite obvious lah. I think you know the answer already, right? You write in the answer bar. Then when I review the answer key, you can check your answer. Okay, so moving on. Done copying the hints, right? Okay, so question number 9 over here. Let me give you some hints also. Okay, instead of me giving you hints, why not you try? I went through the open-ended, it's very similar. You try now? So what you need to do is choose the correct calculation technique. So which calculation technique should you be using? There are 3 of them, right? Can you choose the appropriate one and do now? Yeah, so which calculation technique to use? Okay, so first is, which technique do you use? We have 3, right? Which one is it? Can you flip back your notes? Which technique should you use? So which technique to use? Okay, I move on to the next person online. I move on to Carol. So Carol, do you know which technique do we use for this question here? From on top, then end up below. Does Carol know which answering technique to use? Is Carol even around? Or maybe can I ask Auric? So Auric, do you know which calculation technique to use? Yes, very good. So this question is about the energy at the start equals to energy at the end. So people, you see, every chapter have their own unique way of solving things. Always remember to use the calculation techniques. Don't write freestyle. You write freestyle, then sometimes you might not get it correct. Okay? So now that I taught you that there are three, try to use them. I leave it to you to continue to finish it on your own, Ken, with this hint. Okay, then I continue on next to question number 10. So question 10, I already went through with you just now, so no problem. Question number 11, we also completed the entire question together during lesson time, so no problem too. Question 12, I already gave you the hint, right? Yep, so you should be able to do the part A and B since part C already done. Moving on to question number 13, come, let's go through together. Moments question. So this time round, there is this car being lifted by two ropes, and the car remains horizontal and moves vertically upwards at a constant speed. So you get and then you move up. Okay, so then they tell you all the informations. Yep, and part A, state two conditions for the car to be in a state of equilibrium when it is moving upward at a constant speed. So the answer is actually in the notes. Can you all flip through the notes now and tell me which page number can you find the answer from? Okay, flip your notes. Which page can you find the answer from? Got two conditions. So the answer is like got 2 points. So which page of the notes got 2 points? Two conditions for it to remain in equilibrium. Which page number is it? Correct. Very good. Page 7. You all know which one is it, right? So on notes page 7, do you see that they mention about the resultant force 0, resultant moment 0? And that's the answer. Okay. Moving on to part B, they ask you to do calculation. So same thing, can you refer to notes page 7 for the calculation? Remember, we start off with must always taking moments about where? Then they told you already. Taking moments about the rear wheel, comma, then your sum of clockwise equals sum of anti-clockwise lah. So just refer to notes page 7 for the template. Okay, so I'll leave it to you to do it. Have you copied down the hints? Yeah, copy down the hints so that you can go home and finish it on your own. Okay, so moving on next to question number 14. So for 14A over here, can you do now? Yep, do question 14A now. Do now. Do question 14A now. This question is a little bit different because they have the word like resultant. So if you're not sure what's resultant moment, you can take it like resultant force. So if we were to say that something has a resultant force, then what you do? You will take like the forward force minus the opposing force, correct? That's for resultant force, ma. Yeah, so for resultant moment, also same thing, lor. One moment minus the other moment. That's called resultant moment. Yeah, so use things that you're familiar to like, interpret and figure out how to do for this question. Okay, I shall review the answer now. So by right, how many SF should you present your answers? How many SF to write? 2 SF. So the final answer is 1.5 Newton meter, 2 SF. So what you need to do is you just need to minus off. So this time round you have the weight, right, which is the 4 Newton. So what's the distance? Can you see that it's at the 60 cm mark? That means the perpendicular distance will be 0.4 meter. Then remember, it must always be perpendicular. So if your force is vertical, then your distance must be horizontal. So this would be the one set. Then next is for the ruler itself, it has a mass. Since the ruler has a mass of 0.15 kg pivoted at the 60 cm mark, that means you can ignore it. Then what else? You also have a hold on. Oh, sorry. I shouldn't use the 60 cm mark. I should see the word uniform. Uniform means that the CG is at the center. That means now at the 50 cm mark, I'll draw an arrow down. Wait. Excuse me. And then W equals to mg. The mass is 0.15. G is 10. So that's why now you see, you will have the force as well as the distance. And the distance is 10 cm to the pivot. That means the distance is 0.1 meter. So that's why now you just take the orange one minus the green one. Will do. So that's why the final answer will be the resultant moment is the orange one, which is force times distance minus the green one, force times distance. Okay? Yeah, so it's just the orange one minus the green one. Done. So that's how you get the final answer. For part B, I won't be going through because it's very simple. You should be able to get it right. So part B, I'll leave it as homework for you. So the ones I go through is usually the more difficult ones. Okay, I shall move on. Should be done with correction by now, right? Okay, so for just wondering, for B part 2, do you know where to find the answer from? Which page is it? Can you please take your notes and tell me the page number? Which page can you find the answer for B part 2? So how? Yes, correct. Page 8. Can you write in the hint? Then you go home and finish it on your own hand. Notes page 8. Write down. Notes page 8. The answering technique. I write down the word AT, okay? AT means answering technique. Yeah, so just use the template model answer, then you can score already. Okay, so use the answering technique on notes page 8. Done writing down the hints, right? I move on. Okay, so moving on. Next, question number 15. This one, I already told you just now that A and B part 1 you do on your own as homework. This one, we already did it. Then the next page, we also did it. So moving on to the next question, question 16. This question is super easy that I don't even want to give you a hint. You try on your own. Okay, so this page, you do it as homework. Okay, so yes, we are done for the lesson material. Okay, so as promised, I'll give you the answer key, right, at the end of the session, right? Yep. So let me now share this with you. Okay, so before I give you the answer key, which I'm going to give it at the end of the session, can you all help to give us Google review and appreciate if it's 5 star, please, because now our points is very high. We are at like 4 point, like very high, like above 4.5 already. So if you give us 4 star, then it will pull down the average lah. Yeah, so hope that you see this is like a free session revision for you all. Like we put in like so much effort, print out materials for you all. This all cost money and all. Yeah, so hope you all can like give us a good review also. So since you all are at Bukit Timah now, can you all scan the Bukit Timah form over here? Then you can write anything like about the lesson material today, or you want to talk about like my session. You can quote my name, like how you find my lesson today. I can quote my name also can. Yeah, so just like some description will do lah. Then later, once the lesson ended, right, I will give you all the foolscap pad. Yeah, so if you manage to fill it in, then I'll give you the foolscap. And our foolscap is not cheapskate one, okay? The foolscap is good quality one. It's A zone quality one, okay? Yeah, and very cute also. Yeah, later I give you all will know now. Yep. So appreciate your reviews. Thank you.
My Google Chrome I can't use I think I'm 13 or older. I'm 15.
Yeah, so once you're done filling in the Google review, just go to the page where you can see, your name and your comments and the number of star part. Okay, yeah, so just make sure that I can see your comments appear on Google review, then later I'll give you the footstep pad. Yeah, so you just once you're done submitting, just stand by that page to show me later. I'll distribute later when dismissed. Oh yeah, I got the footstep here. Let me show you. Right, cute one. Over here. Yeah. So is this the footstep pad? I think y'all should be more or less done soon. Okay, so I shall move on to the next slide. Okay, so next is just wanting to let you know that because you attended the event today, we'll give you a special perk, which is if you might be thinking that you might consider tuition next year, maybe because you want to see your EOY result first. How is it? Yeah, so if you intend to apply for tuition next year, right, you scan this QR code. Why? The thing is, this one is to secure you all these early bird perks. So that means, for example, because this one, the early bird perks, there is an expiry date, which I'm not very sure when, I can't quite remember. But the thing is that maybe, for example, you want to register for class, but then you forget the expiry date of all these perks, then you might miss it. But it's okay. As long as you got scan this QR code, at least they will secure you all these perks. And then maybe after your EOY, you realize, hey, I did better than expected, don't need tuition. Then if the overmark admin reach, you just say, oh, don't need tuition, lor. That's it. Yeah, so that means over here, it's not like, oh, you must join tuition. No. It's just to secure you, to get you all these early bird perks. Yeah, which is much more perks as compared to last year lah. Yeah, so for even if you are overmarked regular students, take note, if you are overmarked students currently, you need to scan this also to register for your next year class. Yeah, because we don't do auto auto enrollment into your next year class. Yeah, so you still need to register. Yeah, so I'll recommend that, like, if you're still not sure, why not you just scan, because you can choke you can choke the early bird perks. Yeah, then even if you don't sign up in the end, then just don't sign up lah, it's okay. Yeah. So then you can see over here that they will reserve for you lah. So it's more of like just to yasu and choke things lor. Yeah. By the way, if any of you later have any questions, you can stay back after class to clarify with me anything that's in the booklet today. Okay, so I shall, yes? Previous slide, okay, hands. Sorry. Okay, I believe everyone should be done with like at least the scanning of this one, right? I move on. Sorry, got a series of many QR codes. Still got some more, I haven't finished yet. Even my answer key also QR code. Yep. Okay, so I shall move on to the next slide. If you are not done, later I can come back to this slide after class, okay? Okay, so then next would be that if you are interested in tuition next year, so if you scan this another QR code again, yeah, it will be actually telling you what are the classes next year. So same thing, this is a first come first serve basis. Like I think those students who are in my class, like that time Rian also know that like my class is like always very easily full. Yeah, so it's first come first serve basis. You register first, you are secure a physical slot. If you register late, then subject to availability. So these are the different subjects and lesson timing at the different locations. Yep, so that's me. I'm teacher Felicia. So if you are interested to find out our schedule, you can actually scan this QR code lah to know. Yep. Then you realize, wow, out of all the timing, you can only make it for one, then the more you should register early, because once that class is full, then that's it. So take note, regular overmark students, if you're continuing for next year, need to sign up also. Okay, and here comes the long-awaited answer key. Ta-da! Yep, so can you all scan it and save it properly, okay? So that after you finish the homework, then at least you can check your answer. Yep, so make sure you save it properly in your device. Yep, then done. That's all for today. So hope that you all have benefited from the lesson today. Yeah, and learn all the different techniques, right? What L shape, the calculation techniques and all. Yeah. Okay, so for those of you who have completed your Google review, can you just stand by on the page where I can see your name, the number of stars, and your comments? So you just show me that page, then I'll give you the curated note, the full set paper. Yep, then done. That's all for today. Yep. So hope you have benefited from the lesson. So if you are signing up for the other lessons also at Overmark for this period of September holiday. So likewise, if you are attending online, just come earlier online. Like if you never collect the material, because the teacher will provide you the material. Then follow accordingly. If yours is a physical ticket, you attend physically. If online, you attend online. Because you can see the seats are really limited. Yeah. So if you're having online ticket, should not be attending physically. Yeah, if not really not enough seats. Yep, okay lah, then done. That's all then. Bye bye. If any question, you can stay back to clarify. Bye.